Okay, sorry. Done.
Sir, let me know when to start or if there is something else.
Yeah, very shortly we will start this session, sir.
Okay, sir.
Once we will broadcast this session to YouTube,
Okay.
we will start this session.
Okay.
Okay, done. So, good afternoon to all. I am Dr. Ganesh Prasad from Department of AC and IT Silchar. I would like to welcome you all in the second session of third day of the webinar. I would like to extend my deepest gratitude to our honored speaker, Mr. Abhishek Roy Chaudhary from TCS Kolkata. Before starting the talk, I would like to give a brief introduction about our respected expert. Mr. Abhishek Roy Chaudhary has over 18 years of technology and business solution consultancy experience with a background covering complete software lifecycle, program engagement management, and over 4 years providing technology architecture and performance engineering consultancy. He has developed traditional and cloud-based strategy, architecture, business solutions that have delivered multi-million dollar benefits and has worked in a diverse set of industry sectors across the globe. He also has 8 years of client handling experience in US, UK, Canada, Australia, and Mexico. Presently, he is working as platform architect of TCS Connected Universe platform, especially working on engineering aspects of the product and also owning the solution around merger of IoT and distributed ledger technologies. Thank you, Abhishek, sir, for this session. So now you can proceed, sir.
Thank you, sir. Thank you, everyone. Good afternoon to you all. It's a pleasure for me to come back to my college. I passed out from this college in 2001. So I would like to present something on IoT. How I have divided it is that mostly I will talk about what we have done and then what is my role or what I am doing in that. And then I have kept a particular section on suppose someone is planning, because we have also during my student time we have actually created a lot of pilots, lot of POCs, but we have never taken it to a product kind.
Abhishek, sir,
Yes,
Abhishek, sir, please share your PPT, sir.
sure.
Yeah, it should be in presentation mode.
Is it visible, sir?
Yeah, yes, sir.
Okay. So I will talk about the pickup. So let me tell you the agenda. Okay. So kind of introduction. Thanks, sir, for introducing me. Kind of introduction is already done. I will give you an overview of pickup. Then we'll talk about the distributed ledger. So that's the blockchain solution. We'll also talk about how to actually conceptualize a product and take it to the state where it can be taken to market. And then if there is any question and answers, we can take it. You can stop me at any point of time if there is any question. Okay. So what is TCUP? Basically, TCUP is nothing but a platform, and it's a connected platform. It's a basically IoT platform. Okay. Now IoT means basically a device is talking and all the devices are connected. So we are actually getting some data and how intelligently we can use that data. So it's a platform where we have developed capabilities, and then a solution if someone wants to build a solution on top of it, they can just plug and play and then write the logics about suppose we are capturing some data. Suppose a machine is running, a car motor is running, and the motor has some sensors. So the sensors are actually getting some data, and then we can see, suppose the vibration meter inside a car is sensing that the fan is actually is moving something wrong, right? We have a logic, machine learning logic to understand, okay, the frequency of the fan vibration is not as it should be. So is it a time? So what is the remaining useful life of it? So that kind of things can be done. Okay. Now, Teacup is a basically fully functional, and it can be hosted on cloud. It can be hosted in your system, and it can also be hosted in edge devices. So we have a edge version of the Teacup also. Edge means basically constraint, right? It can be CPU constraint, it can be memory constraint, or it can be bandwidth constraint. So as I said, right, the use case can be from nuclear plants to meters to connected vehicles. So anything actually to as of today in today's world, and specifically after this COVID use case, after this COVID, everything they are planning to be connected. Like presently, I'm working on a solution for social distancing, right? To monitor whether the social distancing is maintained or not. If not, then there is an alert. Inform that something they need to move a bit far away. So that kind of use cases can be done quite easily. Okay. So we have the device connectivity, we have the management of the device. So not only connectivity, if you have to turn on the device, turn off the device, change some parameters of the device. Suppose the speed of the fan has to be regulated. Yeah, I'm giving a very small example. Then data is coming, right? So multiple sources of data would be there. Now the data would be in a way that the data can be a file, the data can be an image, the data can be bits, the data can be time series data, and also like it can be very means the veracity of the data can actually also vary. Okay. So how are we ingesting all the data? So basically the all the sensors would be sending data, how we are ingesting it, and then how we are managing the data. That is important. How we are actually modeling the assets. Like we have a building, okay. Say we are talking about the electronics building. In electronics building, there are 4 or 5 floors. Okay. Now, if suppose we are maintaining the we are seeing that how many lights are actually being turned on. Okay. So each floor, then so the hierarchy of this light, and then the meters of it, right? The meters or the sensors which are actually seeing whether the light is turned on or not. So they can actually be modeled, and the hierarchy of the things can be maintained, so that if tomorrow it is easy to debug. Suppose I have a sensor saying the light is not turned off or on. It's not that I have to go through all. I can actually directly go and say, okay, this is the problem why it is. Then sometimes it is like means all the data is coming and it's a streaming data, right? You have to analyze the data on the stream itself. So real time processing of the data. Okay. Then there is an analytics framework, right? Now all the data are coming. How are we basically taking the data, creating frames of the data, and then we are putting it to different models. uh, Suppose if we need an ETL, merge 2 or 3 sets of data, get something and get a frame on which we have to apply a model. So all those things we have a framework. Okay. And then suppose Teacup is running, but at the same time, you have a very small application which also needs to run, and that has to run with Teacup data. Will you deploy another cloud? No, you can host it in Teacup itself. A small applications can be hosted in Teacup itself. So application deployment is also there. And then most importantly, we maintain its security, we monitor it, and all those things are also there. Okay. So now let me give you so what we actually do. Okay, we say that it's a transformation enabler. Now the industries, suppose a manufacturing industry, they want to say, okay, I have less number of people due to this COVID situation. I want to manage everything online. Okay, so less number of people in the floor. So these kind of transformations, we have the technical, we have given them the technical side of it, technical support of it. Okay. Then the modeling of the data, right? Modeling of devices, modeling of data, and all those things. Now, let me give you a story. Suppose there is a boiler, okay, and within a boiler there are say 1995 kind of features, okay. Now you know that the boiler is working in a say efficiency of 60%, okay, and you have to see if you can actually increase the efficiency of the boiler. Now to increase the efficiency of the boiler, you can actually uh, change the features, but it will be very difficult. It will be very difficult for you to change the features in a physically running boiler because it is risky. It may burst or something, and it might be very difficult also to change some features there. But if you have a model of it, it's called digital twin. If you have a model of it, and then you change the parameters there, you see how it behaves. So before that, so what you have to do is that take all the features of the boiler, create a model of the boiler. Now test it with the present data that is coming out of the physical system and what you are generating from the model, digital model that you have. If it is matching, then you actually tweak the models in your digital twin, see how it is performing, and if it is satisfactory, then you change it in your physical system. Then there is another scenario, okay, like this is an example that we have faced. It's a big European concern, oiling farm. So there are huge amount of oil rigs across multiple countries. Okay, those are set up in different times. Okay, now the data those are coming in or they are actually sending, the data is of varied nature. So how do we actually ingest all the data and then do a synchronization of the data? So there are few forums, right? OPC is one of them. So OPC, OGC, and all those things. How can we actually convert the formats to a format which can be understood by all? So that can be done here. Uh, Edge as of today is like means everywhere you see the word edge. Okay, means in the factory and all, you cannot think that a server would be sitting there, and because maybe as of today the compute and the storage power or the memory power has decreased, but bandwidth is not that available also. Okay, and then you are talking about uh, huge number of machines. That is also difficult. So edge is very important. Now uh, how do you manage an edge? Let me tell you a story. Okay, uh, do you know what is the most secure system in this world? It's not banks, it is a casino. Casinos are the most secure. Now I think it was 1.5 years back, we had a casino in US. Was There was a fraudulent activity, and it was a huge fraudulent activity. So what happened? There was a aquarium under inside which there was a sensor which was monitoring the flow. That was actually someone has attacked it, and through that some damage has been done. Now, when I'm saying edge, it has to be secured end to end. It's not that just I can actually deploy something, get the data. It should be enterprise grade. Your system can be as secure it is, but at the very edge of it, where the at the very end of it, if there is something which is exposed, you are actually vulnerable. So edge at the same time, a secure end-to-end secure edge is most important. So this is then there is like as of today we see so many amount of research is being done on data, right? So many models are there. Now the insights that we get from the data is so humongous. Now I have the data, I have so much amount of data coming in, and if I'm not able to give a platform to data scientists where they can actually uh, read and do create models, understand the data, generate more insight from it, then the data collection is kind of we are wasting that data, right? So we give a notebook service kind of an platform where the data would be there and the data can be understood by doing so many things. Like we have our our own models. You can bring models from Google. You can write your own models. You can bring in them. Then you can run it on your data. You can try to get more insight. Okay. TCAP is basically microservice based architecture. Microservice means we have huge amount of services. Okay. But it's not that you have to buy or you have to use all the services. It's like you choose. Suppose you want device management and you need the asset management. You just take these two. You don't need another 30 or services. Okay. And then there are solutions, point solutions which are ready. Okay. Like as I said, today TCAP is used by few large institutes where they are actually managing the energy consumption, and they have got drastic amount of savings, like where the ACs are there, water, electricity, and you are continuously monitoring, gathering data, and then automating the savings. So over the year, it has given huge amount of savings. Okay. So that kind of solutions can be done. Another small example is in Europe, right? The place is not densely populated. Okay. So remote Europe places where there are meters, electric meters, right? Now, electric meters, if we can understand the meter is going to get bad pretty soon, we go and change it proactively, because their life is very difficult. If suppose in a, it's not about London or something very populated, but it's a remote place where suppose if the power is not there, uh, in this cold, survival becomes a challenging thing. So if the power failure happens, if the meter is bad, then someone taking a truck out, going through that ice, so practical situations are very difficult. So energy monitoring of the meter is a solution that we have, and that has been used quite okay. And then, as I said, right, it is cloud, means cloud agnostic. So the architecture that we have created is agnostic of any. Uh, it doesn't say that I need AWS or Azure. I don't need a cloud also. I can actually install in quite a bit of racks. And then if you say that no, I need just Edge, you give me a Raspberry Pi, a 4,000 rupees kit. Okay, the small feature of TCAP Edge. Okay, you can run on that also. So this is kind of the architecture. Okay. So the application layer is basically the enterprise can plug in there. The data scientists can sit and do their own things there. Okay. Now let me come to this after this diagram. Okay. If you see from this side, okay, this is the device side of it. So from the device side of it, you are actually transferring data. Okay. So if you see, this is like proximity network. Okay. Proximity network like Wi-Fi or something is there, and this sends the data to a edge device. Then the edge device actually sends this to your cloud. Okay. Network access protocol is used. Now, what type of protocol is being used is also very important. Okay. Now, suppose I am saying that my ingestion rate would be very huge. Okay. So, into HTTPS, if I use it, it is secure, but at the same time, SSL termination of every SSL termination is actually very costly. Again, SSL termination, am I talking about RSA 264, or is it something elliptical? That is important. If I am thinking that, okay, I am not, I can achieve the same complexity with a elliptical kind of encryption. If I use elliptical encryption, my performance would be much better. And then if HTTPS cannot support, can we go do it through some other protocol? Okay. So socket protocols are there. So all those things are there. Now we do have for devices, we have QAP. Okay. LWM M2M protocols are there. So protocols are very important, and that is why we need to keep our in the interfaces ready with different devices which support different types of protocols and based on the needs too. Okay. Now, and then there are few places where they will actually say that I will send files. I will just directly send files to you, batch files. So you should be able to upload files that to resumable, right? Suppose you are actually uploading a few GB file size, and then it in middle it gets corrupt or the network fails. You don't need want to start again all over again, right? So, so this side is your devices, okay, this house, planes, or whatever it is, the devices, and this is your edge layer. Here, the edge gateway would be handling, and then it will actually go to your pickup cloud. In the pickup cloud, the first entry point would be your gateway, and then that is your security where it will actually say, okay, like, do I have the authorization, do I have all those things, it is there, and then all the services are there, and then all the services also has RESTful APIs, portals and all, and then they are again exposed to API gateway so that enterprises or end users can use it. So this is the complete picture of it. Now let me go back here. Okay, so this is a technical thing. So what we have is the enterprise layer over here. Okay, so this is our edge devices, and this is the protocols that we support. Okay, and then there is monitoring and logging, and then this is security and distributed ledger. So the distributed ledger is also kind of a security. Okay, so let me go a bit detailed into the services that we have. Okay, the services that we have are like for devices, we have to do a bootstrapping. Now, suppose I have a mobile, I buy a new mobile. Okay, so once I buy a new mobile, it is like I just turn it on, it connects to the cloud, and then I can actually do my registration and all, right? So there is a way it connects securely to the uh, providers, service providers. So I have to have a service where suppose someone remotely tries to integrate a device with Pika, so it should be able to securely bootstrap, okay, and then pre-register the device with your cloud or edge. And actually, thing is that it has to be done with a certificate exchange and all those things. It has to be secure. So bootstrapping is a very important uh, service. Then you have to pre-register the device. After the bootstrapping is done, you pre-register the device, and then the device can be managed. So device management is like whether you monitor the device health, you monitor if the actuation is required in the device or not. And then there would be situation when you see that, okay, some configuration file needs to be changed, something needs to be changed, like the patch update in our mobile, right? Often we say that, okay, Android is giving us a patch update. So similarly, over the year upgrade. Now I have a device, I have a edge box, whatever. It can be a device, it can be a edge box. And I want to suppose I have deployed a model in edge, which actually say, I have a model which actually say it identifies the distance between two persons, or say it identifies a object. And then I have actually improved that model. I found some problem. It was say 90% accurate. Now I have got a way to make it 95% accurate. Now, if I have to deploy that model, I cannot go to all the devices, right, myself, because those are say, remotely. So over the air upgrade, if I can actually deploy the configuration or the model or any kind of change, firmware or software kind of change, so that is over the air upgrade. Then we have in-stream processing. So what is in-stream processing? So suppose a message is coming, say a temperature sensor is saying that, okay, the temperature of the processor, suppose it is a processor I am sensing. I say that, okay, the temperature of the processor is now say X amount of degree. and I say that if it is X amount of degree, you should turn on the fan immediately. So that kind of a message, if I have to do, then if it is a decision taken on that time instant, then message routing can handle. So what is complex event processing? That is, suppose it's coming in this way. Okay, the temperature of this room is 30 degrees centigrade, and also uh, it is very sunny outside, and it is like this for say 5-10 minutes. People are feeling suffocated. Immediately turn on the AC. So there is a windowing factor. Okay, windowing, say 5 minutes, 10 minutes. It can be this many number of records. So any type of windowing is possible. Merging of 2-3 sensor data is possible. So that is complex event. Now you have taken a decision. Okay, I have identified that the a event has happened. Like the temperature has been crossed, or a event like 2-3 sensor marked, and I saw that okay, heuristically some changes has to be done. Okay, now who will do that changes? For that, action service is there. Action service is like you need to alert some people. Okay, send an SMS, send an mail, or suppose you have to do something else. You have to send it over to another enterprise. You have to call an API of that turn on the AC. It is managed through a separate kind of an enterprise system. So call that API. So it can call that API dump it in a database. It can be internal. So that kind of action can be taken. Now, there are other things, right? Now, data is coming. Huge amount of data is coming from so many sensors. Now, how we have to? Most of these sensors are data, time series data. And now, two things we have to say. Okay, one is once the data is coming to us, we have to keep the data, and also we have to make sure that the data is suppose I want to get it, that fetching it should also be efficient. So what type of data store is required? So that is a very important thing. Okay, I am ingesting huge amount of data, and the data is written to a place, and then uh, like I'll tell you an example. Postgres is a very famous database, right? Mostly people use Postgres, but Postgres, clustering of a Postgres is not possible. Now, there is a failure. There is a failure, and then the Postgres is not available. That particular Postgres is not available. What will happen? So, how can you cluster the data? Is it like, is it a time series data? Do you need to use InfluxDB, or is it an object store? You have to use something else. So that kind of decisions has to be taken. Okay, so that kind of decisions, how to make the data efficiently stored. Okay, now the data is coming in such a huge volume that if you maintain and store all this like as it's coming, the amount of storage you will consume is huge. Do you want to go for a reduction like Parquet and all? So keep it in a Parquet format. Okay, 60%, 70% kind of reduction that you will get instantly. Then you have data lake service. Okay, so people from different places, from different enterprises, or even from your own systems, they want to dump something to you so that it can be used. Like task service works on batch processing, right? So how, where from it will get the batch file? Someone will call, means the data frames will be created, and the files will be dumped in the data lake, and the task service will call it and take it. So this kind of thing. Or suppose I have to take a decision on many things, right? There are so many number of sensors are coming, and then I have to also give a benchmarking of it so that the model can run through it. So the benchmarking report is actually directly uploaded in the data lake service so that the model can directly use the benchmark report, and then the model can function. So that kind of use is for the data lake service. Now let us go to data pipeline. Task service is basically normally models are created, or the models are also run. Sometimes the model is on streaming data, like for images, it would mostly be on streaming data. But there are some cases where you want to do it on batch mode also. So for that batch mode, you have the task service where you actually create the data on which you want to run the model. The model is actually created on the notebook service. So if you see the data scientist workbench is there. So notebook service, you create the model, you deploy it in your batch service, so the task service, and then the task service will run it, generate the output. You can also create a workflow of this, like, okay, these two, after this task, run these two tasks, and then after this is complete, run this task. So that kind of a workflow also is possible. Then you have data visualization. Creating the data, you are running the data, then you want to see the data, right? So the data has to be visualized. So you see the data. And then and I think I already spoke about this pickup analytics and notebook services, right? So that is actually the most important thing, okay? Because data scientists will come, try different models, data engineers will come, try to merge this data, that data, and if I don't equip them with good amount of easy way of just playing with data, then it's not a good use of their time. Okay, so that is something that we have to give. Then monitoring and logging. Now, if I have to say, how are we deploying it? Okay, we'll have to make it portable, and at the same time, it has to be like robust. Now, uh, we use Docker. So one level of virtualization is VM, and then on top of it, there are Dockers. So we just deploy the containers, and then the orchestration of the container can be done using Kubernetes, or it can be done using Docker Swarm. So whatever is the enterprise decision, that can be done. And then suppose there is a suppose a system, a Docker fails, so the orchestrator will automatically turn on and create another Docker. So those kind of monitoring and all those things, auto recovery from failure, can be handled in this monitoring. Okay, and then the logging is there. uh, this logging is basically the complete system is logging here. So a data, once the data, like the from the end data entry point to the end of the data, if you want to understand the data lineage, okay, now where the data got changed, where the data is like residing now, and what is the life cycle of the data, and all those things can be actually identified from that logging and efficiently once we're logging this thing. Okay, so, using these complete services, we can actually create two things. One is the digital twins, digital threads, and all those things also can be created. It's the platform. Using this, we can create all those things. Now, if I think I have already said about digital twin. Digital twin is nothing but, if think it in a way, that it is a virtual device. It's basically the device is modeled digitally, and then that particular device, we can play with the digital device, identify the best configuration, and then it can be deployed into the physical system. One use of a digital twin. And digital thread is basically, I have means from production of a design of a particular product to the use of it, and if I slowly get the feedback coming in from the use to the design phase, that is the digital thread. And from the time I'm designing this, and then designing is done, it is deployed, it is being used, and then during use, I am seeing that, okay, these are the problems I'm facing. So if I can feedback that amount of data to the device back again during the design phase, so that I can modify the design, that is the digital thread. And this should be all connected. Now the complete thing, data is like democratized, right? So all the data is available to all, and every stage is connected. So that is a very good way of seeing that how we are helping to get digital. Okay. Now I think I have already covered this. Now let me go to edge services. I will take a pause here. I will see if there is any question or not. Let me see how to go back. Chat.
Sir, questions will be provided by the attendees at the end of the session.
Okay, sir. Okay, sir. Fine. I will can continue.
Okay. Thank
Okay, so this is the edge device. Okay, in the edge device, basically, it can be a Raspberry Pi, it can be a Jotex box, it can be a NVIDIA Jetson. Okay, so NVIDIA Jetson is kind of GPU enabled, so for video and all those things, it is quite easy to use. Raspberry Pi and others. So basically, few architectures are there. Like ARM architecture is there, and Intel architecture is there. So which architecture you are using? So you have to identify those, and based on that, you have to create your own Dockers and all. So again, all the agents are there, and then this is the way it is connected. So if you see in the edge, you have a message broker. Message broker is nothing but for this whatever you have seen, right? Like MR, CP, action, and all those things. We have to use a the way we are using it. This is kind of helping in that. Okay, like event management is there, right? Event management, so they are also very event. So real time processing is there, OTA is there. Okay, so it's kind of everything is there, whatever in a small way the complete cloud solution is there, but the footprint of it is very small, very small. Okay, it can actually, so I'm saying a Raspberry Pi is like 2 GB RAM and 4 core. So in that kind of device also it runs, not at its full capacity, but it runs. Okay, and then it can connect to your cloud devices and take. So basically you are taking decision near to your source of data. Okay, now let me go to the engineering part. Okay, so why am I going to this? Because let me tell you one of my work. Okay, I work when one of my patents that I have applied for is like is a edge device. Okay, edge device, as I said, right? It is very constrained. Okay, and then the continuous pumping of data actually can turn off the system, turn off the edge device, or it can make it unresponsive. So what I've done is I've added a queue on top of it and a layer of ML on top of it. And once I'm actually see so many services are running, so I can get the system performance features. So I am getting system performance features from the CPU, from the memory, so basically from the system and also from the containers, Docker. Okay, I'm getting so many amount of features. So using the ML and also our own knowledge, we did a feature extraction. So out of this amount of features, what all features are quite useful. Using that, I actually the model is trained and we can identify, okay, after 5 minutes, if the ingestion rate is such, this ingestion rate has increased or something has happened to the system. If it is such, if I don't control one of the features, the system is going to crash, and the ML can predict that. And the moment ML predicts it, it actually give a rescue time to the edge device. It actually writes it in a queue, and then once the device is again back healthy, it actually slowly pumps all the data. So that is an small work that we have done, and we have submitted it to different places. So ML edge is a quite important thing. Okay. Uh, okay. Now, if you see number one is develop scientists or data engineers are getting access to notebook services. In the notebook services, they get PyTeacup, PyETL, PyAnalytics. So these are libraries that we have created. Okay, PyETL will help you to like merge or create files, frames, basically data frames, using multiple sources and the what data you want to. So basically ETL service using Python library. Then PyTcup is there. There are different ways of interacting with different services. Okay. Now you want data from say source, sensor of observation. So you don't have to write anything. You just call that library from PyTcup. It will get that particular file for you. Okay. You don't have to do all those things. So that is done. For TCup, any access PyTcup is there. And then we have our own libraries created, analytics libraries created. Okay, you want to do a say or whatever is there in analytics is given, right? You want to say you want to do a data imbalance, like suppose your number of positives is actually far more than your number of negatives, then the model that would be created would be skewed. So how do you actually remove the imbalance of the data? So those are actually normally taken care of using those libraries. Now means for data signal processing you have this kind of libraries already created. Okay, then like to understand means to play with the data, to understand the data better, you can also use the descriptive analysis. Then the RRN is there, predictive analysis, and then health index or RUL, remaining useful life. So these are very important, remaining useful life and health index. These are very advanced. Like for machines, we get some data from sensors. So these sensors can be actually sending us data. Now there are ways that suppose we are getting some amount of some different types of data, and you are actually transforming it into strings using the preparation of data, and that we are using this in RUL kind of thing. And after the preparation and identifying, okay, what is the remaining useful life of the device? So that actually gives a heads up that you need to change that device, or you need to call a mechanic. You have to do something for this, otherwise there will be a time when it will fail and your shop would be stopped. So this is very important. Okay. So number one, you have data scientist. Data scientist is basically coming in and get working with your data. Okay. So and then they are what they do is they create some models. So the TCAP OTA model will actually then deploy it to TCAP Edge, where it has to be deployed. If you see number 4, and then it can also deploy it to 5 TCAP task services. Okay, and then all the data, all these things can be, all the observations can be actually posted into your data lake service also. So this is the normal life cycle of a uh, data engineer kind of, and data scientist. Let me do a time check. It is 3. Okay, I'm doing good. Okay. Now let me go to a yeah. This is, I think, already I have discussed. Okay, smart energy management. If you see here, I'm not going to read through the, but I very important thing is around 1900 for one organization only. 1900 19,500 CO2 reduction has been decreased. That is, uh, it has been rated 3 to 5 star. Okay, that's a huge uh, benefit that has been given to the environment. Okay, and then it actually improves the organization's respect also in the market. That is a green company. Okay, so if you see using TCUP, a particular organization, the amount of savings they were able to do. This is again a complete. This is a very big organization, and what it has done is it is using TCUP for greater speed to market. Okay, they have from aeroplane engines to nuclear plants to everything. So it's a very big concern. And from there, they're using TCUP to say to create faster time to market, right? So it will create solutions very fast using the services already there in TCUP. Okay, this is already again means the oil rigs are there. So many oil rigs are there. If I have to get a end-to-end view of it, and The moment I get an end-to-end view of the data, I can actually analyze and do a better performance, right? I can assess the data. So this is what we have done in Pickup, right? We complete oil rigs. There are a huge amount of, I think they are world's number one or second in terms of oil production. So for that, the complete thing has been done. Okay. And this is a printer company. Okay. The printer company is having printers all over the world. Now they came to us saying that okay, we need to update our software time and again. So what we do need to do is that we need to go there, update there, or send a CD, send a floppy disk. There's some people are there. They call us, then we update. So many things are happening, and it is not a good way of doing things also. So driver update. So we help them with the OTA. Okay, now it's like mobile update only. They suppose if an US company they want to update their driver in say Australia, so it's just they will update it and it will be done. Okay, using OTA service. Now let me go to distributed ledger. I will not take much time here in the distributed ledger. Uh, I will quickly go to the section which I wanted to discuss more. Okay. Now, what are the three things that a distributed ledger is important for? One is uh, if there are multiple source of data, okay, then there is a distrust, okay, and then there is suppose I have think about a hospital and I am a firm who gives them X-ray machines. Okay. And I say that okay, you can use this X-ray machine from say morning 8 a.m. to evening 6 p.m. If you use then per use you give me 100 rupees. Rest is yours. And if you do it after 6, then you give me 200 rupees. So that kind of an agreement is there. Okay. Now there are two sources you see. The hospital is actually having a entering the data from when it is used and all those things, how many times it is used, and then I am the person who has rented it out, and I am say, setting the rates and all those things. I am doing a compilation, and then there is a distrust. I say that no, you are using more. He is saying no, you are using more. I am using less. So rate discussion and all those things. Okay, that is the time when a distributed ledger can come handy. Like what it will do is now let me go to an enterprise example. Just an example for sake of example I'm saying. Okay. Say Rolls-Royce has built an engine. Okay. If aeroplane engine has been built by Rolls-Royce. Now the Rolls-Royce engine has been bought by Boeing, and in US the Boeing has created a plane flight. That flight has been purchased by say Singapore Airways. And then the Singapore Airways is running the flight. Now there is a downtime. During the downtime, the huge amount of money has to be paid by either Boeing or Rolls-Royce. So there is an agreement. They enter a consortium. So there are three validators here. One is Rolls-Royce, one is Singapore Airways, one is Boeing. So the data from the system, from the plane is coming in. They are also monitoring it, and the data from them also can come. Okay, they can say, okay, the system, we see there is a problem in this aeroplane. This Boeing says that you immediately look into it. So that kind of a communication. Otherwise, there will be a failure. Rolls-Royce says, no, no, that is fine, it is good. And then say Singapore Airways doesn't take an action, and then they fight about it later on. So nothing, you have not said anything, and there is a downtime, you have to pay. So there is this is I'm taking a simple example, and you can understand it can actually lead to a loss of life also for litigation. So in that kind of situation, distributed ledger helps. So what it will do is that suppose there are three validators. If someone wants to post something, that posting has to be done only if two people can validate that the input given by the person is correct. So three validators I'm saying here, right? So one is Singapore Airways, Rolls-Royce, and Boeing. So Airways wants to write something. So how it will write? So they will go, and the the thing that I have created is SGX. Okay, SGX is nothing but Intel has created in their own processor space. It has actually have a secluded place where the encryptions are kept, and then if it is tweaked, the complete and validator would be taken down. That place cannot be ever used. So that kind of encryption is there. Now, suppose Singapore Airways wants to write something and the encryption has been done. So there is a one-way syncing done between these three processors where these things are hosted. Okay, so it is that secure. Processor itself is actually giving the encryption keys, and it is secluded and you cannot touch it. The moment it understands that there is a problem, it will actually take it down. So that's secure. Now, Singapore Airways wants to write something. If one of them, so these three of them is there, right? The message is coming into the network. One will be elected leader. Now, they will immediately say, okay, I am free, I am the leader. Say Singapore Airways becomes the leader of that particular transaction. Now, the moment it gets 50%, more than 50% vote in that way, this particular record would be written to all the things. Also, say Singapore Airways has given, say I want to write it, and it becomes the leader. And Boeing says, okay, I agree. This is a validated message from Singapore Airways. Then the message is written to all three places. And in future, no one can actually tamper that. So it's a hash kind of hashing is done, right? So if you play with the hashing of that particular message, the complete tree, Merkle tree. So it's basically a Merkle tree. The complete Merkle tree fails. So now what you have to see is that, so there are three important things. One is there is a distrust. There are multiple sources of data, and then there is a chance that you want to make things immutable. So these are the three things which are important for identifying a use case of um, distributed ledger. See, blockchain and distributed ledger is kind of different. Okay, in an enterprise, what I am talking about is a distributed ledger. So it's a ledger which is distributed. It's not centralized. So digitization of a contract or connect is required. If it is yes, then it is still there in the race. If it is not required, then okay, don't use blockchain or distributed ledger. You want the data history to be auditable. Okay, if yes, then you use, because you want to make it immutable. If it is no, you cannot change the history of the data, then you don't need it, because then there is no way you can fight it. It is immutable already. You want to make it immutable, that is why you are using distributed ledger. Data is centralized, so data is created from only one place. If the data is created from, suppose in this example, the data is only coming from Singapore Airways always, then there is no need, right? Then Singapore Airways can write anything that it wants. So here the data is not centralized. And definitely, is speed the only thing? If speed is the only thing, then distributed ledger might not be the right answer. Then you have to go for something else. So that is also some. So what we have created is basically, as I said, right, for three cases, three validators are there, and then there will be proxies. Any number of people can actually write to it using APIs, and multiple validator and multiple nodes are supported. Okay, suppose in Singapore Airways only, so there are different lines of businesses. Okay, one is ticketing and all those things. Okay, in say Boeing, you can say that someone is actually doing the frames, for instance, the body of it. Someone is doing the engines. Someone is doing the wiring. So all those are different departments, and they can actually write to it. Okay, they can get the data, write to it, but only one validator, and all these lines of businesses can be nodes, client nodes. Okay. Now, the how the architecture can be, or rather the architecture that we have. So there can be a cloud section. The cloud can be hosted in Tckup or it can be outside Tckup. In the enterprise also, if you see the right hand side, the enterprise also there is, it can be a like suppose in Singapore Airways they don't take a cloud, they are actually on-prem, they are on-premise, they are doing something. So they can, so in on-prem also they can have two options. One is just client node or they want a validator. If they want a validator, then it is a validator kind of a thing. So it can also be hosted in an edge. Okay, that is the beauty of what the service that we have created. Normally, distributed ledgers are very costly. The consensus and all those things are very costly. But we have successfully tested it in Atom. Atom is kind of a very small Intel edge box, and I think it was also working in a Raspberry Pi. So it is the smallest. So that's the best thing that we have done. Like it is very, very efficient. And what we have done is basically we have taken, so there are multiple blockchains available already, distributed ledgers available already. So you can take any packages. We have taken a package from the Linux Foundation. We have created our own transaction. So we have created our own pickup transaction. We have defined the transaction, and there also we have a few patents. We have created a few patents there. Uh, and one of the patents I can say, like it is very interesting. Uh, suppose when once you are creating the models, right, and the models are being created, um, you have a data, like on the data on which the models have been created, and if you get a way to tamper that data, the models created would be incorrect. Suppose you have created a data that see the condition of the land and weather, and if it is right, then water the plant, water the ground. Okay. And I have tempered it. And then when water is not required, it is going on watering the plant, and the plant dies because I have got a chance to tamper with the data. So if I can say that the model is, so the data used by the model and the model itself, how can we use distributed ledger efficiently there? So that is the kind of pattern that we have applied for. We have given a solution to that. Okay, now comes the part which I wanted to discuss quite a bit. Okay. See, as of today, we see a lot of advertisement coming in, right? Most of the companies have started from a garage. Uh, this guy has started coding in at the age of 9 years. At the age of 21 or 19, Facebook was created. At the age of this, uh, Amazon was created. So this kind of advertise quite a huge amount of. I think it is from White something, right? The coding company. They're actually giving. According to me, I was also from Hostel 4. Now let me tell you one thing. What I'm seeing here is, see, my friend is the chief evangelize officer of TCS. He is my batchmate. And then there are my friends are actually, means I feel very proud. They are in so good positions. Okay, the best brains are there near you. Okay, and they are very friendly. After say, I'm taking mostly people who are staying in hostels and all. After a few years, you will see some of them becoming the MD, or someone is technically taking the shots. So friends are there. If you think that, because India is also supporting startups like never before, and in hostels you have the best brains. Near you have the best brains. If you can think about startup, then do think about it, because that will actually, suppose I know from, I'm from Silchar itself and I have studied in NIT Silchar. Uh, and for that geography also, it will be a very good thing. Some employment opportunity for the local. The people like me have to come out of the place and all those things, right? Now, one, in our time also we have created a lot. Okay, we have created a lot of software. I know we have created using Perl, a chat machine, and we benchmarked it then that it was faster than Yahoo. And that guy who has worked with me, Vishwajit Das, is in UK now. He has a startup. Okay, so this kind of things are there, but we have never pursued it because we have never thought, our views were not. And but now the internet is there, and the institute is also getting huge amount of faculties, a good amount of help. So things have improved drastically. So if you think about few things, four things in particular, while you are actually planning something or discussing something, if you think four things, what is this license of the open source that I'm using? How the security of it would look like? What should be the engineering property of the enterprise that I'm thinking of? And how can I deploy it? It can be a very small thing like a like in future, if you think, okay, I want to inside the campus, I want to monitor things. Okay. Now let me say that, okay, I will put everything in a CCTV camera. Just for an example. Maybe this is not a good example, but just for an example. Now, how do you think the important the engineering properties are? Suppose I'm thinking about one particular IP camera. Okay, one particular IP camera in a very low resolution. Say one frame will be, say for an example, 2 GB, 2 KB. For a bandwidth, it is nothing. 2 KB can be. Now think about the complete campus, or say think about the complete electronic building itself. In electronic building itself and the complete all the educational buildings that we have in NIT, suppose 1000 cameras of such type is required. Now you think the bandwidth. 1000 into 2 KB and the frames per second, say you are taking say 5 frames per second. So 5 frames per second. So per second, what is the bandwidth coming? That is the engineering property challenge coming in. So the multiplication that happens once you think that it will be deployed by an enterprise, the amount of complexity increases, has to be thought once while you are designing it. Just for an example, I gave that. It can be some other solutions also. And then the deployment of it, whether it would be deployed in an Android app, or it would be an iOS, or it would be a system, or it would be in a cloud, all those things. Now, a few things which are actually coming very handy is like, if I have, many people are thinking AI doctor, right? AI doctor, if you Google AI doctor, it will come. AI doctor will come. I have also tried my hands there. And then you create an Android app using AI doctor. What it will do, you give your symptoms, it will say, okay, you need to visit a doctor or not. You need to visit. You can actually create a doctor, AI doctor. And you know, right? AI doctor means normally the doctors that we have are accurate to a particular percentage, say 80%, 85%, 87% based on the geography. But AI doctors have actually say they are saying that it is more accurate than the physical doctors. So this is a way of, suppose you want to create something and then you want to take it to a massive scale. So you can plan that. Okay. So the license, important license. Suppose I'm the example I've given you, right? The camera example I've given you. The camera you are using, the most common library is OpenCV. Suppose you are using Python CV2. Now, Python CV2, you have not taken care of it while you were compiling or building the OpenCV package, and FFmpeg comes in. FFmpeg is, I'm pretty sure all of you know. And FFmpeg license is not good for commercial use. You have to purchase those. Suppose you are using a format of the codec which needs to be purchased, okay, and you don't know it as of now. So this kind of a bit of research on the technology you are trying to build in the license. Suppose it is an Apache 2 license, it is an MIT license. Just go ahead and use that. No problem. You can use it. You can use it for commercial things because if you can go ahead with your one particular release or one enterprise, you can actually then actually create a good journey. Okay? And we all will be proud of you. That one person from NIT Silchar is having a who knows a company like Facebook tomorrow. So choice of technology is very important. Okay. Often what we have seen, and why I'm saying is because once I have been into this, presently in the innovation lab, TCS Innovation Lab. So this is the research wing, and that is where we are creating this product, Pickup. It has matured now, so we are actually going to the next step. And in this research, before that, I was also in the different in the services, then consulting, and all the things. Once I'm in product, I actually understood how a product can be built. That is why I thought that this might be a good topic. Okay. Now the choice of technology. Okay. People just come back and say, I have seen many people coming and say, I need a software with a distributed ledger. Okay, you need a distributed ledger, but why? Are you asking that? Means because I cannot ask it to a customer, frankly, because there are many things. But is it a hype that we are going in? Means I need a software with analytics. Okay. Now, what is analytics? You know, right? If then else is also an AI. That is a heuristic. How many types of chatbots can be there? In chatbot, you can actually say if someone, these are the questions, these are the answers, this question, this answer. It can be a chatbot, and it can be our complete vector space. Something will read the complete web, understand the learning in few hours, and then from there it will start using NLP and NLP. So, so the range of AI is from heuristics to that. So, what are we making? What type of technology we need? And is it that we need that only, right? Right technology or not? Are we not going through a hype? Are we going through a hype? So that kind of a question you have to ask. Then, as I said, the license check. Okay, many softwares you can build now itself, and then you will see, okay, it is completely functional, it is phenomenal. Then you are taking it to the market. You say, oh, I cannot sell it because the license itself is not working. Okay, it's I have to purchase it, and I understand once you are actually at that stage, you purchasing a license and then selling it would be very difficult. Okay, so check the license before, and there are many open source alternates for kind of almost everything. Think about the scalability of it. Okay, you are using it for an enterprise, how it can scale. Suppose the example I've given, right? The cameras and for your complete campus. Where how many edge boxes? Suppose the all building can actually do an edge, and I can reduce the data to be going to the cloud or the main server. So I have to reduce the complexities at all the points. So that is the scalability. How do we scale if required? Suppose the number of frames are increasing. Like now taking that particular example to the next level. Okay, I have five FPS. My FPS is 5, and I have say 1,000 cameras and 2 KB one frame size. And I now do say that there is a I will take every 6th frame. So basically per second one frame. Okay, I will take only 6th frame. Now, if you are saying so, if you don't do anything extra, still your bandwidth is being consumed. The frames would come. It's just that your machine will not take it, but the bandwidth is being used. Bandwidth of your LAN and the your inside device. Okay. So how do you control that? Okay, that is the engineering, and that is one of the thing I have just completed working on. And how can you reduce the use of bandwidth? So this is something a real engineering challenge. Okay, And it helps when you are talking about thousands and thousands of cameras. If you can reduce the user bandwidth when you are doing a like, I will take 6 frames per second, uh, and I actually stop the frames from the source itself. How how to do that? So that is very useful. So less use of bandwidth. Okay, so this is one. Then the usability is very important. Usability is like how friendly is my software to use. If I have created something, if it is very difficult to use, it will be not very popular. People will not use it. Okay, so usability, the UX of it should be very important. And then the high availability and reliability. Suppose you have created a very good software, and suppose you are willing to give it to someone for free also, but if they don't see reliability of it, if they don't see high availability of it, enterprise will not go for it, because their business would be at risk. That they have used it for a year and then they see the system has failed and it cannot actually come back again and restore back, or the data cannot be restored. uh, their complete business is actually at risk. So you have to give a way of high availability and reliability. And these are, frankly speaking, today's technology are so advanced, using cloud, using like blueprint deployment and all those things. It's just a matter of time you read it. It's not that it's a complete empty rack. You have to do everything for you yourself, right? You have the DevOps has improved a lot. Like you can actually go for Kubernetes kind of orchestration, or for a small thing you can go for Docker Swarm, or in the cloud itself there are so many things are there, HAS and all those things are there. It's not a very rocket science as of now for high availability and reliability. All things are there. It's just that you need to put your mind into it before you start. Okay. Uh, like technology also, you need to understand, okay, which technology works with which technology. A Java technology and the database which is not compatible with Java might not go together. Okay, and then a complex system, I should use as much as rationalized software as possible. Okay, and then your performance decreases drastically if there is a language encapsulation. And suppose I'm jumping from a way lower to a higher um, language, all those things have to be. So deployment flexibility is there. I've said about security. I'm actually trying to rushing up because it's 3:42, and I try to keep a few minutes for questions if there is any. I don't know whether I'm making sense or not. So the endpoint security, I think we have given that example of that. Yes, sir.
Yeah, Abhishek sir, some questions have been posted in chat section. So please
Okay.
answer. Yeah.
Do you want me to complete it and be very fast and then try?
Uh, sir, actually, I didn't get you, sir.
Do you want me to complete the slides? I think there are two more slides. Just
Yeah. Yes, sir. Yes, sir. You can continue.
okay.
Mhm.
So the communication security is important, right? Okay, now I am actually from one server to one server. I am actually moving. My data is moving. So is that particular tunnel secure? Is my data which is going from one place to another is encrypted? Then do we have fine-grained access control? Uh, like suppose a person is a developer, doesn't need access of a manager. I am not giving him the access of a manager and all those things. Okay, my manager doesn't should not have the access of a developer. If developer will have more access to the data and all, for that he can play around. So all those things. Okay, fine ways. So the controls has to be there. It should be hardened. Okay, like as of today, I am pretty sure once you are actually downloading Ubuntu, you see that the Ubuntu is coming up with huge amount of things. The size of the Ubuntu can be around 3.4 GB or 4 GB, 5 GB. Okay, but you know, right? The Ubuntu is also there in the edge devices, and they are actually under GBs. Okay, so hardening in means you just keep those software which is required for your system and remove all the other software which is not required, because sometimes The softwares which are not required, there is a vulnerability, and that vulnerability is exposed. Okay, so that is one. And data at rest. Suppose my data is at rest in a particular data store, and that becomes exposed. We should have an encryption so that people cannot play with it. So that is the security. Few things that is very important, like tools are there, online tools are there. Some tools are free also. So just in case you are planning for software and you are yourself want to take it to market, think about these few tests. Okay, SAST, static application security test, dynamic. So just Google it. Means I'm just trying to say that this is important for you to plan a software and take it to market. Okay. Apart from creating the software, there are so many things that actually is required, and then you can take it to market. Okay. Then you have to do benchmarking, capacity planning. You have to identify hotspot. Uh, then one more important thing is very much important is your disaster recovery and housekeeping, data backup, archival, and housekeeping. Okay, these two are very important. Okay, the recovery means how soon. Suppose the system has failed, how soon I can be back and start the services again. So this is one. Another is my data volume is going on increasing. How can I actually chop it and store it, archive it? This is one. And another is suppose my data I'm using is corrupted somehow, and then how is that I can actually take the data from the backup and then continue with my services. So these are the few things which are very important. Okay, thank you. I will now try to take the questions. I'm not sure whether where to go in this chat. Okay. So, what are the essential things one should to become a data scientist? Okay. See, one thing what it's a very good question. Okay. There are three things that we do once we say that we are a data scientist. One is we create data for the data scientist. That also we say it is a data scientist. Means this is one of the most this is a term which is used in a very wrong way. Data scientist, data engineer. Okay, they means I am actually preparing, pre-processing the data, cleaning the data, reducing the noise, and suppose there are millions and millions of data. I'm using Bart's algorithm and I'm reducing it to say 1,000 rows. Okay, so that is also a work, but this is a work of data engineer. Okay, then how comes like I am there are so many number of models there in Google, in TensorFlow and all those things, right? I can use them. So what is a data scientist? Data scientist means when you are actually very good in mathematics, you are very good in discrete mathematics, you are very good in statistics, you are very good in vectors, you are very good in metric spaces, and you are actually creating a model which can be like a model for the TensorFlow. Say say someone is using for object identification yellow v3, you are actually contributing to create yellow v4. So that is a data scientist. So that job is very very rare and very niche. So your one thing I will say, to understand or to become a data scientist, your mathematical background should be very good. How can I make a use of a make a how can I make a decision tree? uh decision tree you can sorry you can make it using there are many models as of today, random forest and all those things. And if you want to say that how can I like using entropy gain, you can do that. But means I am not understanding whether it's an academic question or is a software question. If it is an academic question, then maybe I think you need to go through uh, the entropy gains and all those things. But you have to understand that before you are using anything, because if you want to be a data scientist, then this is very important. Bitcoin and cryptocurrency, which is more secure, or they or see, Bitcoin and cryptocurrency are kind of same. Bitcoin is a particular vendor. It's like antiseptic cream and then Dettol. So Dettol is an antiseptic liquid, and so Bitcoin is a means pioneer in cryptocurrency. There are many cryptocurrencies as of today, and security of Bitcoin and cryptocurrency. See, of late, people are actually saying and recognizing cryptocurrency, but there are many questions how secure they are. There are way more number of fraudulent activities using cryptocurrency. So maybe I'm not the right person to answer this.
Abhishek sir, I have few more questions, sir.
Yes, please.
Yeah. Sir, your services, do you take care of latency over the network?
Not really. See, latency over the network is there definitely, but we have tried to optimize it as much as possible. Like, uh, uh, see, I will tell you, where it was used to take say 800 or something CPU, we could achieve up to say 60, 80 kind of CPU. So that kind of optimization has been done, but latency would definitely be there, sir.
Ah, okay, sir. And sir, what are the policies has been taken to minimize the energy in your services?
To minimize the latency.
Energy consumption.
Energy consumption. So see, our what we have done here is basically we have given a platform to capture all the data. Then the policies are actually created. Means we have given them the platform. These service owners have these people who have created the services. They have actually read this. Suppose I will give you an example. In Saturday afternoon earlier, the whole building ACs were used to run. Okay, so they said that when the number of people is less inside the ODC or where the people work, if the number of people are, then it reduce the capacity of the AC.
Mhm.
Okay. Suppose they have identified, okay, if people are not there, turn off the lights. Okay. So those kind of policies, but you have to see that it has been done across, okay, and 24/7. So the amount of gain that has been received is huge.
Okay. Sir, okay, sir? What is the complexity of your services, sir? Which type of hardware actually required? Uh,
So it depends on where you are using it. Okay, I can use it in a Jotex box also, so that is an edge device. And mostly people are going for cloud, where when for a big systems like it, sometimes we need around 150 cores to 150 to 200 cores, and with say RAM of around 500 GB. That is also required. Means you need to understand like what is the volume of data and what is the like who all are consuming the service.
yeah, yes, sir. Okay, sir. So last question is that can academician get the project from your companies for the development, sir?
Maybe I'm not the right person, but there is a way of. Means I know TCS is hugely involved with academics, and there are a lot of collaboration. Means I personally is working with one of the projects with IIT Kharagpur. So
Oh,
we actually work a lot with academics here.
mm.
So, but that is something has to be taken at the corporate level.
Okay, sir. Okay, okay. Thank you, sir.
Thanks a lot for this opportunity. It was pleasure.
So, sir, I will conclude the session, sir. Okay.
Yeah, thanks a lot.
So, we, the participants, especially, show our highest gratitude to you, sir, for being with us and sharing your valuable knowledge and experience with us. We would like to thank Mr. Abhishek Roy Chaudhary for taking out time from his busy schedule and providing us with an opportunity to learn from his wide range of research, experience, and knowledge. We are sure it will be a big learning experience for all of us, and all the participants must have benefited and noted down ideas for their future research. Sir, we hope to get such opportunity in near future also. Thank you, sir.
Thanks a lot, sir. Thanks a lot.
Yeah. Thank you, Abhishek.
Thank you, sir. Thank you.
So we'll see you in future course.
Sure. Thank you, sir.
Okay.
Okay. Thanks a lot.
Thanks.
Thank you. So our next session will resume at 4:05 p.m. by Dr. Rahul Hussain Laskar. The topic for the talk is dynamic gesture recognition. So now it is 3:55. So Rahul sir, we will continue after 10 minutes or
Yeah. Sure. I just wanted to say thank you to Abhishek. So that's
oh,
the
yeah,
reason. He just agreed with my one call actually, and he's my student also. So I
yeah,
thought of giving a big thanks to him. Okay.
yeah. He's very knowledgeable person, sir. I think very good.
Yeah.
Okay. Rahul sir,
Yeah. Mm.
so should we continue this session?
Yeah, sure.
So, good afternoon to all. Once again, I would like to welcome you all in the second session of this webinar. I would like to extend my deepest gratitude to our honorary speaker, Dr. Ramul Hussain Laskar, from the Department of EC and IT Silchar. Before starting the talk, I would like to give a brief introduction about our respected expert. Dr. Rahul Hussain Laskar received the BTech degree in Electrical Engineering from Regional Engineering College, Silchar, in 1998, and the MTech degree in Signal Processing from the Indian Institute of Technology, Guwahati, in 2007, and the PhD degree in Electronics and Communication Engineering from the National Institute of Technology, Silchar, in 2013. In 1999, he joined the National Institute of Technology, Silchar, as a lecturer in the Electrical Engineering Department. At present, he is working as an associate professor in the Electronics and Communication Engineering from the National Institute of Technology, Silchar. He has more than 19 years of teaching experience at NIT Silchar. For the last 19 years, he is involved in teaching, research, and various other administrative activities at NIT Silchar. His broad area of research include speech processing, image and video processing, biomedical signal and image processing, machine learning, soft computing techniques, communication engineering, and other areas related to signal processing. He has more than 70 papers in different reputed journals and 60 international conferences and around 10 book chapters in image, video, speech, biomedical, signal processing, and other fields. He has supervised 11 PhD students and supervising another 8 PhD students. He is carrying out 5 sponsored projects by various sponsoring agencies like HDIETY, BARC, SERB, etc. And 3 are under review process by SERB and SPARC. He has supervised 12 PG theses and one more is going on. He is the reviewer of various international journals and conferences such as Applied Soft Computing, Image Science Journal, Applied Acoustics, Speech Communication, IEEE Transaction on IEEE Industrial Informatics, IEEE Access, Neural Computing and Applications, Journal of King's Sword University, Journal of Intelligent Systems, IET Journal of Research, Signal Processing, and few of them. He is involved as TPC members in various conferences such as JIS conference, SPIN, UTC. He has research collaboration with IIT Guwahati, IIT Dharwad, LNMIT, Jaipur, BML University, Noida, and various other institutes. Thank you, Rabu sir, for your session.
Okay. Am I audible?
Yeah, yes, sir.
Oh, yeah, Ganesh.
Yes, sir.
Yeah, the slide, I mean, this is not coming. Can you please send Sharul?
Sure.
Yeah,
Yeah,
yeah, yeah.
yeah, he's coming, sir.
Yeah. Yeah, sorry for the interruption. So, I mean, let's check it out.
Yeah, yes.
দেখো সংকিতা হইলো share entire screen করিয়ার তো share no PPT full screen করে দেই না slide show from the current slide. Okay. Good afternoon, everyone. So, yeah, myself, Dr. Harich Lashkar, Associate Professor, EC Department. So, sorry for the delay. And I'm very thankful to Dr. Ram, the brief introduction about myself. So, I believe I need not go for any further introduction. Anyway, so the today's talk is titled as Dynamic Hand Gesture Recognition System for Human-Computer Interaction. Basically, I'm the lab in charge of the speech and image processing laboratory, and it is a research lab, and most of the works that are being done under my supervision in this particular lab that I'll be going to show you out, and what we are doing and how we are doing it, and how far we are able to make a progress in this particular direction. So this topic, dynamic hand gesture recognition system. So it's fall into the broad area of research that is known as the human-computer interaction, and I'll of course explain the hand gesture, why hand gesture, and what is the dynamic hand gesture. I will be going to explain during the course of time. Okay. So the way I try to plan out my talk is I'll go for a brief introduction, then about the dynamic hand gesture, and then we'll see what are the research gap, and then we'll try to move over to the database that we prepared at the NIT Silchar and the system that we developed during our initial phase, and finally conclusions from drawn from our studies, along with the future trend of work or research work that can be done, and finally some references that we made use for this particular study. So as I mentioned, there is a dynamic gesture basically fall into a broad area that is known as the human-computer interface, and human-computer interaction basically is to act as an interface with the user, like the traditional keyboard, the mouse that we are using, or the joystick that we are using as an interface to the computer. So other than this, there are different other modes of interfaces like face, hand, then that body. So that can also be made use to interact with the computer. So accordingly, that one, that is the face, human's face tracking, hand tracking, face recognition, facial expression recognition, just hand gesture recognition, body pose recognition, etc., falls under the category of the human gesture, human computer interface. So the thing is that face. So if we say that there is a face is one of the mode of interface that we can use. The hand can be also made as one of the mode of interface, and then the body, also human body action, can also be made as a interface to the human computer interaction. So these are basically called the gestures. That is, it's something like signing on the air. That is, you are going for a contactless kind of communication. Nowadays, the traditional keyboard or the mouse or other the joystick that we are making use of, or even the touch screen, these are basically traditional devices that we make use for the human computer interaction. Okay? For inputting our data to the computer, and then computer does the number crunching and do some kind of processing and provide us the output, or take some action based on this particular input data. So the input device is basically the traditional input devices are basically the keyboard, mouse, or joystick, or the touch screen that we are having. But the other than this, some non-contact kind of interface, like the in the morning, the Professor Prasanna was talking about the speech kind of interface that we basically make you nowadays. The Alexa is there. That one he mentioned about the Google Talk. Also, there we can make the speech as a mode of interface to communicate with the computer. So this are basically, this is barbell but non-intrusive but barbell mode of communication with the computer. So there are non-verbal modes also, like facial expressions, like waving your hand, or showing the victory symbol with the hand, or throw some body movement. So we can produce the gesture, and this can also be made use of for interacting with the computer. So gestures, basically it is observed that the gestures basically provide a natural way of interaction between the human and the computer. So the objective of recognition is, given the input, or you are signing on the air with a gesturing device, maybe your hand, or maybe your facial expression, or may through the body. The objective is to recognize what information you are trying to convey. The objective of the recognition system is to identify what information you are trying to convey, and accordingly build a model out of it, so that it can recognize the gesture and control certain kind of applications, or do some kind of processing that you want to that you are intended to do. So so as I already mentioned, that face can also can be used as one of the mode of interface for human computer interaction. The body gesture and the hand also can be made use of as one of the interface. Here in this particular webinar, we will be focusing on basically on the hand gestures as the mode of interface between the human and the computer. So the hand gestures, it may be a static kind of gesture or a dynamic kind of gestures. So what basically the static and the dynamic gesture is? For example, when I am asking for showing one, so I'm just showing only one finger, so that indicates the one. Then for two, I am showing the two fingers. So this is where the movement is of the gesturing element or gesturing device is not there. So that kind of gestures we basically called as, for example, the victory symbol B I am showing. So this is basically a kind of static gesture. But when I am writing something on the air, say for example, two I am writing on the air. So these two, the finger need to move. For example, I am using the index finger to write it, or I am using the hand to write two on the air. So here the whole, hand has to be moved. So this kind of gestures are basically called the dynamic gestures. Then comes the discrete and the continuous gesture. The discrete gesture, for example, I'm writing say only two. So this is only two. This is a kind of discrete gesture. But for example, I have to write my name on the in the air. So for example, I am writing Ram, RAM, Ram. So this is a kind of continuous gesturing, because the gestures, multiple gestures are all appearing in sequence. So that kind of gestures are basically called the dynamic gestures. Okay, so here we will be mainly dealing with the dynamic kind of gestures, where the gesturing device move across during the gesturing process, and will be of course dealing with the discrete as well as the continuous gesture. So now coming to that one, that is the gestures that as observed from some of the literature, that in our day-to-day life interaction, a human-to-human interaction, basically, that 65% of the communication are basically non-verbal kind of communication. By the term non-verbal, I want to mean that basically that kind of either we give a smile or some facial expression or some body posture or some kind of hand movements and all. And through this, we try to communicate with the other people. So 65% communication are basically non-verbal in our day-to-day life. So and the rest of the part are basically verbal, that is the oral kind of communication, that is the speech as the mode of communication. So this gives an idea of the importance of that non-verbal mode of communication in our day-to-day life, and can we encash this particular information that we want to that we communicate between the human to human, can we replicate on the machine, and can the machine be made intelligent enough to recognize this particular gesture and respond to us? So the in virtual environment, basically the hand gestures make more specific and informative gestures as compared to the facial or body gestures. The reason is basically that human hand is having more degree of freedom, as I have written over here, that is 27 degree of freedom as compared to the body movement or facial gestures. So being the more number of degrees of freedom, so the hand gesture is able to communicate in a more intuitive way or more natural way as compared to the facial or the body gestures. So coming to the gesturing device, that is input device, the gesturing through which we have to capture the gestures. So basically they may be classified into two categories. One is basically contact based, and another is basically vision based. By vision based, I want to mean you have a camera and maybe 2D camera or 3D camera, and you will be gesturing or signing in the air in front of the camera, and camera will gesture the movement, maybe facial, maybe hand, or maybe the body posture. So it may be a 2D kind of data or a 3D data that will be captured, and that will be made used for further analysis. And in the contact-based kind of thing, I have mentioned that data globes or magnetic tracker, this kind of device, they are basically put in the hand or in the body to capture the signal. So, there are a lot of application of the contact-based systems such as data globe or magnetic tracker. People are doing a lot of work and a lot of devices are available. But here, in this particular work, what we try to do in our lab, so what we try to do was basically using the vision-based 2D approach. That is the 2D camera we basically made use of. The reason behind this one, using the 2D kind of devices, camera is basically a simple webcam fitted to your computer, or which is there in front of me. So that can be used as a data acquisition device for capturing the gesture. So it provides a low cost solution to us, and moreover, it is basically contactless. And nowadays, if you see that, we're during this pandemic kind of situation, nobody dared to touch any public property like in the ATM machine or other kind of public computer or system. Nobody dared to touch any kind of keyboard or mouse or any kind of interface, or even nobody is interested to use the smartphone of the other to make a call and all. So in this kind of scenario, a non contact based kind of system, like a vision based approach, that using the 2D, that is with the low cost camera like a webcam and all, and non-verbal mode of communication, that may be an alternative solution to our traditional kind of keyboard or mouse or joystick or even the touch screen, I believe. So for with this particular information, what we try to do is we try to look into the several application areas, And we have seen in the different kind of areas, like for example, information visualization or desktop application, sign language recognition, robotics, virtual reality, or ubiquitous computing. One thing is that is common is that they have mouse and the keyboard, and data globe or remote contact devices. So this part, that mouse and the keyboard, is basically one of the integral component. Okay, so what we planned out is basically, can we substitute? I mean, I'll not use the word substitute exactly. Can we use an alternative interface device that will be non-contact, not non-contact based, non-verbal mode of communication. Why non-verbal? That I will be going to discuss. Why non-verbal mode? And I mean a low cost kind of solution. So with this particular thing, we started our work, and we tried to have an alternative to the traditional keyboard and the mouse. That can we have an alternative kind of system, an interface system. So that is what is our objective, and with this particular objective we started. Then there are different other areas of application like sign language, robotics. Some of the application areas I'll show you later on, where a lot of people are doing the work in different universities as well as the industries. And gesture control medical application is one of the areas in the medical domain. So it is observed or reported in some of the literature that the transmittable diseases, most of the transmittable diseases that are from the computer or keyboard, mouse that are used in the ICU or the operation theater, and the nurses and other people, they make use of it, and when the next duty shift, another nurses and other people are going, so they got, I mean, transmitted with that transmitted disease, with this communicable diseases. So I mean, so can we substitute? If we are able to substitute this particular traditional keyboard and the mouse, then we can reduce this particular disease, I mean that transmittable diseases from one person to other, and thereby we can help the people. Even in the smart home application, for example, even I mean, we have a lot of people, aged people in our home. They have the a lot of disabilities, and movement also is very much restricted. So can we make use of some application? For example, the AC is running and they try to, I mean, reduce the, I mean, temperature. So they can just gesture out that make a gesture, and the temperature of the AC will be, I mean, reduced or increased, or okay. So that way, the government of India has the concept of smart city, smart home, and so that smart, can we make a smart home in that way? Or some of the application, this old people or the person with the disability, they want to run some of the applications. So with the limited movement, can they able to run this kind of application through the gesture, sitting at a distance apart without moving? Even sometimes we observe that the people used to forget where they have kept their glasses. The aged people, they used to forget. So I mean, this kind of, for this kind of people, if you want to, I mean, they used to forget the remote and all where they have put it. So for this kind of people, the gesturing device, if gesture is made as a substitute, so they need not to remember where they have put the remote and all this kind of devices, that is interface devices, they have put into. So that may be one of the alternative to the classical, the remote or other kind of devices in the smart home application. Okay, so I mean, I personally remember that once I visited to one of our, I mean, principal is an aged person. So I mean, I asked him, sir, what are you doing these days? Can you, I mean, will you write some book or something? So he was telling that, yeah, I try to write some books, but the problem is basically I cannot continuously sit on the terminal and type lot of stuffs. Then I told him, sir, why not using the Microsoft speech to text engine for I mean writing something that will you can sit and you can just speak out, and the system will be helping you. Then he told me that there are a lot of problem with the accent and all, and it is really, I mean, the correction also become very much difficult. So that way, that even then I thought that can we have certain kind of alternatives? Say, okay, the gesture be used instead of the keyboard, and we will be sitting leisurely and sitting in front of a camera and just gesturing out, and the system will go on typing on his behalf as we do with the traditional keyboard. Okay, there are numerous such kind of examples that we can cite, and I mean that kind of gesture, which is 65% of our mode of communication in day-to-day life, can it be made a useful tool for helping this kind of people, maybe aged people, or the person with the disability, or the person having other kind of I mean diseases like Alzheimer or other kind of diseases? Can we make the life of these people easier? So in this direction we thought of, and we tried to come out with some of the ideas, and we submitted the projects, and we got two projects funded from the ministry, and one is running at NIT Silchar under my supervision, and another is my first PhD student. She is doing at LNMIT Jaipur. And in that way we started doing our work, and a lot of students, at least the 2 students got their PhD, and 3 more are in the queue to submit their thesis. So this is what is the achievement we got out of this idea that we tried to I mean nurture out and try to implement in our laboratory. So as I mentioned over there, is our objective is the person will be signing in the air, and the system will be capturing the image or the video, rather it will be video, and from the video it will be analyzed, and it will try to identify what is being gestured, and accordingly some action will be initiated. Okay, in case of replacement or substitute for the traditional keyboard, the stuff will be basically somebody will be writing continuously, and that text will be appear on the display screen, and that will be of course stored in the file, like a speech to text engine is doing in case of Microsoft speech to text engine. So this is what is our ideas. So can we have a replacement? I will not say replacement, an alternative to the traditional keyboard and mouse based interface system. Okay, this mouse here in the NIT Silchar, we are basically dealing with an alternative to the keyboard, and our partner at IIT Guwahati, they are basically looking for an alternative to the mouse that can that be realized through gesture kind of basically hand gesture kind of system. So I mean, looking into the market penetration of this hand gesture kind of recognition system, here is one of the slide that I have taken from some of the publicly available sources, and it's seen that it is observed that I mean the touch screen as well as that one traditional keyboard and the mouse, they are dominating the today's market. And basically the gaming application in the mobile phone or the smartphone that we are using, the touch base, it's mainly touch base. So I mean it's touch base kind of stuff is basically dominating in the portable kind of devices, whereas in the gaming kind of application, the accelerometer and the marker globe kind of interface is basically dominating. Nowadays, what we observe is in the Microsoft Xbox that Kinect sensor is they have the gesture as one of the mode along with the speech kind of interface. So this is now coming into the market. A lot of products are coming into the market, and the gesture based kind of interface is going to penetrate into the market. And I believe with the COVID, 19 kind of scenarios, I mean, this penetration will be more and more in the various application areas. Okay, so when we thought of, I mean, designing a system, dynamic hand gesture recognition system, that is replacing a traditional keyboard or a mouse with a gesture based kind of interface, the problem comes up in from the different angle, that is inaccurate detection of the gesturing devices, then presence of imposter, then hand trembling. And the hand trembling, basically for the aged people, the hand trembles more when they sign on the air. Then different people gesture in a different way. For example, if you see the simple A to be written, there are two kind of pattern that will be coming. One, somebody write the A with a single self articulation. I will be referring the self articulation. Self-articulation basically means an unwanted stroke. So if you see in the, the way the people are writing A, you will see that they are having the two different patterns in the writing the A. Their start point, end point different, number of unwanted stroke is different. Unwanted stroke is not a problem when you are writing on the paper, basically, or when you are using the traditional keyboard. The unwanted stroke is not a problem. Even in the paper, when you are making the pen up and pen down to, I mean, the control the unwanted strokes. But when you are signing on the air, the camera is not able to differentiate between the unwanted stroke and the wanted stroke. So I mean, it takes up unwanted stroke also into account. So the actual, I mean, gesture that consists of both the unwanted and the wanted stroke, and that unwanted stroke needs to be removed. And that is also challenging when the pattern variation comes. The same gesture, they come with the different kind of, I mean, unwanted stroke, or number of unwanted stroke is different. Then then when we see, even when we are writing with pen and paper, the speed, the way one person is writing and the other person is writing is different. This happens for the, I mean, gesture, hand gesture also. If some person write a very faster rate, some, in case of continuous gesture, some people write in a very slow speed. Even within single gesture, for example, if we ask to write A, somebody write A very fastly, and somebody used to write a small at lower speed. And this is true for very prominent for the aged people or the person having the disabilities. There, I mean, the speed goes down like anything, and it really creates a problem. Okay, then the scale variation, I mean, that one, that is the distance from the camera to the person who is gesturing. So that distance matters, and matters a lot, and accordingly there is a scale variation. And this scale variation problem, that is the size of the image or the resolution of the image, that gets become different, and that needs to be addressed out. And moreover, I mean, in the traditional keyboard, you have more than 100, I mean, keys. And out of this, basically 95 are printable. So we targeted that initially that can we replace these 95 keys, 95 keys, that printable keys. So I mean, it's basically a good set of characters, and there are a lot of characters with a similar pattern, like one and slash. Then I mean, zero, oh, they are having, I mean, very much overlapping in nature. So I mean, these characters are very much overlapping in nature. So I mean, I mean, so that the vocabularies that you are going to select to design your system, that also affects the performance of the system. Okay, then there comes other problems such as illumination variation, then uneven movement of the hand, then occlusion, I mean, partial overlapping, and then background effect. So all these restricts or become a technical challenge in designing the system, a practically realizable system that can provide a sufficient level of accuracy to be really become a deployable kind of system or an alternative to the traditional keyboard or the mouse. Moreover, when you are going for a continuous gesturing, for example, you are signing on the air and writing the RAM, RAM, RAM. So there is, I mean, both the kind of stuffs are there. The one is within the character, there is a there are unwanted movement. As I already mentioned, that A can be written in the two different ways by the two different user. I will be going to show you, and that creates the problem. Like, I mean, that is known as the pattern variation problem. This is one of the thing. And then when you are moving from one character to another, then there is a movement involved that is also an unwanted. In the pen and paper kind of scenario, this doesn't appear, but in a gesture, when you are going for the hand gesture, this also being captured, and that is what is known as the movement epenthesis. So the movement epenthesis in the self articulation, we need to distinguish it out, and accordingly we have to isolate the characters. This part is R, and this part is A, and this part is M. So that need to be isolated and fed to the machine as a discrete character to recognize that yes, this is R, this is A, and this is M, and when combined it become RAM. So that way, I mean, there are challenges that comes into as we go on from discrete gesture recognition to the continuous gesture recognition scenario. So there are other issues also. So as I mentioned earlier, that I mean, there are a lot of, I mean, real life example that of course motivated us to go ahead with designing a substitute for our traditional keyboard or the mouse or the joystick or even the touch screen. And there are other kind of motivational factor that we observe from the literature. Is there is no exhaustive study that has been done so far on the hand gesture recognition. I mean, I'll show you out with reference to certain literatures that how much they have done and what is the progress they are able to make. And then there is no, I mean, practical or real life substitute for a keyboard or the mouse kind of interface, virtual text anti-interface system. And even in the robust bare hand detection, this robustness is one of the factors. That is the performance under different conditions. That is one of the challenging factor. Then pattern, scale, speed variation that I just mentioned, that are also a lot of challenges, and people, I mean, partially did some work or they tried to do a little bit work in that particular areas. And there are inefficient imposter detection methods. That is, imposter, I want to mean that, for example, yeah, I'm using the skin. If the skin color object is there, so this one is going to act as an imposter, and that creates a problem. Or if I'm able to making use of a red marker and a red object is there is in the background, that creates a problem, and that is what we call basically the imposter. Then the vocabulary size, as I mentioned, like as you go on increasing from a lower vocabulary to the higher vocabulary, then I mean number of character and their similarity increases, and that creates degrade the performance of the recognition system, and thereby degrading the performance of the overall system. And there are of course new feature engineering and the modeling techniques that are available, so that could have been explored, and that is one of the lacking that we try to observe in the existing literature. So this also motivates us to look into dynamic hand gesture recognition for designing a dynamic hand gesture recognition system. So once we are going to design a particular system, a replacement for or alternative to the traditional keyboard and the mouse, so what we need to consider is basically some analysis that need to be done, a comprehensive analysis or influential factor on influential factor. So these are some of the parameters that I have mentioned. There are different other parameters. For example, the responsiveness. What does the responsiveness basically means? That the system should be able to, I mean, capable of real-time recognition of a gesture, and For example, the learnability. The learnability means that the gesture should be easy to remember. It should not be a mental load. That is low mental load, as I have mentioned also. That it should not be a mental load in the user that I have to do in that way and that way. You should not be remembering too much about the gestures. So intuitiveness, it should come in a natural way. Come as you can. That is, it should be it should come in a very natural way. And introspection space means it should be able to, support lot of, or should be able to interact and adapt to lot of other interacting devices. So that way, there are a lot of papers. So a lot of, factors that we need to look into when we are going to design a particular, gesture as an alternative to our traditional system. And we I mentioned one, a similarity of writing a note on a piece of paper. That is easiness is one of the vectors. The writing on a piece of paper, that comes in a very natural way to us. So even we don't feel stress, or when we are typing, or when we don't, we feel stress, but that has become a natural process. We take it in a easy way. So when we are gesturing, it should not be a kind of mental load, or it should not be a burden on the part of the user. It should come in a more intuitive way, like that we used to write on a piece of paper. Okay, so that is one part. And then what it comes is, that is when the system need to be implemented, or it should be deployed, then we have to use the different kind of user. It's not that a group of people, young people with all this kind of having uh, abilities to do any kind of, so that work. So that should not be only taken into consideration. What we did was, we took the person with the physical disabilities, we take their responses, person with having partial hand strength, then the person aged, as well as the adult group. So all this feedback as well as the data need to be collected, and accordingly the system should be designed so that the system can be close to the real environment and can be a more deployable kind of solution. So in a dynamic hand gesture recognition, so various steps that are involved is, you require a gesturing device, that is the input device. So as I mentioned, that we are using the 2D camera, and the gesturing device is basically the hand. So in case of the hand, you can have the two ways out. One is, you can just make use of the index finger just to make a gesture. For example, I want to write 2, so I can move my index finger in the air, and I can write 2 on the in the air. Or what I can do is, I can make use of my hand, and I can move my hand, complete hand. So this is another way out. So when we are making of the index finger, so there is one marker that need to be used. We call it red marker. Basically, the red, some kind of, say, red pepper is put on the index finger, or a red vermilion is basically put on the index finger, and that way the index finger is moved. So it is basically called a red marker kind of base gesturing device. And when we use the hand without any marker, so complete hand we make use of, we call it as a bare hand kind of gesturing device. So both are having advantages and the disadvantages. We did the analysis on this particular issues also, and what we observed is basically that one is more natural. That is first one, that is making the index finger with a color marker on the index finger is more natural, and fatigueness, as well as it is more close to the writing on a piece of paper as compared to the moving the complete hand. Because when you are moving the complete, and then the muscle movement is more and the stress is more, and for the long kind of writing long paragraph or long word, it may really become a difficult, because whole hand has to be moved continuously. But when you are is making use of the index finger, so it's really easy to move, and it can it can be thought of an alternative to a simple pen and paper. and that we did a good analysis using the different user feedback and I mean designing the system and then taking the user feedback, and we observed that I mean they're quite satisfied with the red marker. But the problem with the red marker is that you have to put something on the a red object like a piece of paper, as I mentioned, has to put on the index finger. So something you need, you have to carry some kind of I mean that, and otherwise it may not be available also. So I mean that is one of the drawback of that one, the red marker kind of scenario. But on the other side, if you see, it has some advantages. So both the system is having some advantages and disadvantages. So what we try to do was we try to analyze both the system from our own perspective and see how the system perform, and what is the accuracy level of accuracy we are able to achieve. And as I was mentioning, I mean that the device that we are using, the acquisition device that we are making use of, is basically a 2D camera, like a webcam that is connected to my machine now. So a simple webcam can be used. So the solution can be a low cost kind of solution, okay? Because nowadays all the mobile phone or smartphones or any electronic devices, they are having inbuilt cameras and all. So our motto was basically, can this be inbuilt devices? Can it be used to devise a new an alternative to keyboard and the mouse, rather than I mean going ahead with the new kind of device or costly device and all. What is there in the inbuilt to the system? Can this resources be utilized to design a system? Okay, so additional hardware and additional requirement will not be there. Only the processing part that can be done on the hardware. So then, I mean, once we decided about the input device, so it's detection of the input device followed by the tracking of that particular input device that I'll be going to show you, of course. And then gesture spotting, that is identifying the trajectory of the gesture, then feature extraction, and train the model during the training, and during the testing, test the model. And once the gesture is being recognized, so it can be made use for a particular application. So in our case, the application is basically a keyboard system. So when we look, as I told you, when we look into the literature, what we observed is we land up with a lot of issues. Like, I mean, if you see, they are using the data globe in the first case. So data globe, as I told you, is basically, it is not vision based, it is contact based. So contact, something has to be connected with your hand and all. So that one is not preferable to us. We are looking towards a vision based kind of, that is non-contact and non-verbal kind of stuff, interface. So what we did, what we observed is they are using, I mean, the data globe kind of stuff in the first paper. Then the second paper, they are using the skin filtering kind of technique, and that is having the problem if some of the skin color objects are there in the background, that also I mean the tracker fails in that particular scenarios. So, and other than this, the database they made use of very limited. For example, in you can see only numerals, that is 0 to 9, they made use of for their study. So I mean, as our aim is to have a substitute to the keyboard, so what we require is basically, we require not only the numerals, we require some symbols, special characters, moreover the uppercase letter, lowercase letter. So we require a lot of things. So that may not be a, a workable kind of solution for our problem. Similarly, there are, I mean, different other issues, like they have not considered the self-coarticulation gesture, rather self-coarticulated gestures, like, I mean, the gestures where unwanted strokes are there, or they made use of a single pattern only, that they restricted, they put a restriction that the user has to gesticulate. We call, when producing the signing on the air, we call it basically gesticulate. They have to write in a particular given pattern. So that kind of restrictions are there. They try to put into on the part of the user, but in a practical scenario, you cannot impose lot of constraints on the user. So what our objective is basically, can we make the system, I mean, as simple as possible, so that any user need not to, I mean, be I mean, trained to use that particular kind of system. Okay, so that is what we thought of, and accordingly there are a lot of limitations also that you can just see, that in some of the cases the system works on the clean environment, then it provides the poor accuracy. Okay, so for some of the cases, for example 0 and the 6, they are basically very poorly recognized by in this particular paper. So I mean, here is a paper they use the to I mean, replace the cursor or mouse. So but in their case, it is observed that they got a very poor accuracy, and it was working in the clean environment, not like background, having a complex background or dynamic background. So that kind of situation they have not considered into their study. Similarly, when we looked into the bare hand database, we observed that even though their systems are giving reporting, they are reporting very good accuracy, but they are doing the I mean, experiment on a very limited kind of database, or their gesture may be only static gesture, and they're maybe on a very clean environment they are doing the kind of experiment. So by going into the literature, what we observed is basically neither this kind of systems can be put into a practical solution to design a deployable kind of system. So we have multiple issues. So we thought of addressing the some of the issues during initial phase of our work. So this initial phase of our work, what we try to do, that I will be going to discuss, and what is our observation that I am going to highlight. So we try to design the 5 different systems in our laboratory, and the 5 different systems are basically, one is with the as you can see, with the reference gesticulation, speed, and the pattern. This is our initial system. So what we did was, like the previous papers, what they did was that I mean, we fixed also that a particular gesture has to be put in a particular pattern, following a particular pattern. For example, different people write a different way, 5 different people write in different way, but we didn't allow the user to do in that way. We allow the user that you should write the A in this way, B in this way, C in this way, and with this speed you have to do it, a speed that we have decided based on certain kind of observation. So this is one of the experiment that we try to do. And then what we do is we try to relax the condition. For example, we now allow the user that you can gesticulate in your natural way, of writing A, natural way of writing 5, natural way of writing Z. But I mean, so that we allow, but the speed should be maintaining constant. So that is the 1 degree of freedom we have given to the user, and that way we allow, in the next case, we allow the user to that he or she can vary the speed also along with the pattern. And then in that way we try to do the speed and the pattern variation, how the system behave if we relax the condition one by one, and how the system behave, how the accuracy is affected, and how the system performance degrades or improve that. And if the performance degrade, then what should be the mechanism that we should adopt to bare hand is also has certain kind of applications of its own. For example, you need not to carry any kind of, I mean, marker, or you need not to search for any kind of I mean, red objects to put in the index finger. So it has its own I mean, advantages. So we try to look into the bare hand kind of system, and we try to design a bare hand system and we try to see what is the performance this system gives. And finally, and we try to uh, 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 see what in case of continuous gesture, are we able to, once the model is ready, I mean, can we make a discrete gesture recognition system to a continuous gesture recognition system? So that is what we also tried to explore during our study. So as a first step toward that, in when we thought of implementing this particular system in our laboratory, what we observed is we require a database. We search throughout the literature and through different website. We found that there are some of the databases are available, but no database, as I have mentioned, shown over here, but no databases are basically publicly available, and the number of gestures are basically very much limited. Okay, so this databases, we requested even to provide their databases, but nobody responded. I mean, or we didn't get any response from them. So what we thought was basically, can we prepare our own database? Okay, so in this particular direction, we try to prepare our own database, and that we make, of course, publicly available, not the full database. As I mentioned, that two projects are simultaneously going on. So being a part of the project, we cannot make it publicly available right at this moment. But I mean, but samples of the database, we have made it available in this particular link. So I mean, we have the first database that three problems, that is the reference pattern and the reference speed. If you ask the user that this is the way you have to write A, B, or C, and with this particular speed you have to write. So this is one part of the database that we prepared. Then we buried the pattern, and then we buried the speed, fixed the pattern and buried the speed. So in that way, we prepared the three databases to see the performance, how the performance is degrade with reference to database one, when we free one, we provide 1 degree of freedom to the user. Then, the second case, in the bare hand database, we do the similar kind of, database preparation by fixing the pattern and the speed, by providing 1 degree of freedom to the user to vary his pattern or the speed. And we have the other three databases in case of the bare hand. And then we also prepared the continuous hand gesture database also, because no database is publicly available. So we need to prepare on our own database, and this was a commitment to the funding agency, that will provide a good amount of database. So this was a commitment also to the funding agency. So anyway, this is a sample of the database that I will show you how we prepared our, whether it will work or not. So this is how prepared. You can see a red marker is there on the index finger of him, and he is signing on the air for this particular character, and the character is it is gestured out. So you can see there was an unwanted stroke also into that one. So you are not able to understand what the character he has written, I believe, or maybe he may have made the guess, but the computer will not be able to make it out what character he is basically gestured. Okay, so this is another video for the bare hand. You can see, so in case of the bare hand, that you can see that, yeah, she is not using any marker in her hand. So what she is doing is she is just gesturing, and she is trying to write the character 3, I think 3, yeah, 3 or 2. She is trying to write 2, okay, by signing and or moving her hand in the air. So this is how we prepared our database, and we put certain constraint on the user for, because these are the initial studies, so the database should be perfect enough. So we put some kind of constraint in the users. For example, the hand should be visible, there should background should be no red marker object should not be in the background, because this, if some red marker object is there in the background, this creates a problem during the tracking process or trajectory formation process. So we put some certain constraint on the user, and we try to prepare our database the way I have shown you. Similarly, we try to put some constraint on the user during the bare hand database preparation, and the hand should be moving for sometimes, and it should be at the end position, it should be hold for at the end position for some time. So that way we try to put some kind of constraint on the user during the preparation of the database. And the device, as I told you, is basically that we use a simple Logitech webcam, and these are certain specifications. And finally we collected 38,800 data for color marker, and for bare hand 11,600 data, and for continuous gesture we collected 50 continuous gesture. For example, a sequence NIT Silcher. So this is a sequence. So like this, the 50 sequence we have collected from the different user that we have selected. For example, we selected 30 user, we have 20 male and 10 female. So initially we have not taken all the 95 printable characters from the keyboard. What we tried to do was we limited our application. We limited our application in the sense that we thought that initially we will be designing only a numeric calculator or a hexadecimal keyboard kind of stuff. So a hexadecimal text and interface, or a simple calculator. For this calculator, a numeric gesture calculator to be designed, what is required is we require only 10 numerals and the arithmetic operators. For hexadecimal text and interface, what is required is we required A to F in addition to this. But what we did was we take A to Z complete uppercase letters. So in that way, we are having 40 characters that we have taken for our study, and we try to design our system using the 40 characters. Okay. So the system one. So what we did was we developed the first system. We tried to make use of basically the different existing feature. Along with this, we try to propose few new features, and we use the shallow architectures. Basically, we try to do some kind of feature engineering and use the shallow architectures for designing our system. So here is the block diagram of the system. That is, you have the input video, you segment the color marker, that is I will show you out, and then we form the trajectory, smoothen the trajectory, and then the self coarticulation. Generally what is I told you is basically unwanted stroke that has been avoided in most of the literature. But in our case, when we are introducing the character from A to Z, the self coarticulation is also there. Self coarticulation is inherently there, and when we bury allow the pattern to be buried, the self coarticulation come into picture. So one our aim was, can we instead of leaving the self coarticulation, can we make use of this self coarticulation as a piece of information, to boost the performance of the system. So then along with the existing feature, the self coarticulation features and other new features that we try to design, we try to feed into the classifier, that is the shallow architecture, and try to see how the system perform. So with this is our character set that we made use of 0 to 9, and then A to Z, and the 4 arithmetic operator, and that is required for designing a numeric calculator, gesture-based numeric calculator, or a hexadecimal text and interface system. So this is how we try to identify our this one, that is red marker object. It goes, it takes the first frame, and then extract the R channel, because this is the RGB color space. So R channel is being extracted, and RGB to gray conversion is done, and then subtract one from another, you will be getting an image, and from this image being filtered out, and we got the final output, and this is what is the our region of interest. So from the region of, once the region of interest is being identified, we find out the centroid, and then the centroid is being tracked down the other subsequent frame to form the trajectory. Then we smoothen the trajectory using a standard algorithm known as Douglas-Pecker algorithm, because the trajectory is noisy, and this is basically the trajectory smoothing or filtering is basically done using the Douglas-Pecker algorithm. So this is one of the video that shows how we did this particular stuff. So this is a gesture using the color marker, and as you can see, this one is being gestured out 3. And what is happening is, once the Douglas-Pecker algorithm is applied on the top of this one, so this is the final trajectory that is coming out. So once we are able to identify the trajectory, so what we have seen is which are the characters that are having the self coarticulation. So this is a character 4 which is having one self coarticulation, like A. As I mentioned, that we have fixed the reference pattern, so there is one self coarticulation in that particular case, but A written in a different way may have 2 self coarticulation. But we have we have the reference pattern and the reference speed. So in that case only one self coarticulation. E has the 2 unwanted stroke, F has the 2 unwanted stroke, H 1 unwanted stroke, H has the 2, and so on and so forth. So so there is a lot of self coarticulation, and in that in the existing literature, what they basically do is, the 4 they ask the user to write in such a way that the self coarticulation doesn't appear. But in a natural setting, when the user is writing, so what is our objective does not to instruct the user or give some he should not be having some kind of burden on him, that he should remember that this, if you want to use this particular system, I have to remember that 4 should be written in a particular way without gesturing. So that burden we try to relieve from the user. So that way, we thought of, once a gesture, unwanted stroke is appearing in the gesture, so either we have, first one task is we have to identify it and remove it. This is one thing. But in addition to this one, second approach is, that is, we can identify it and we can make use of it in addition to the existing feature extracted from the wanted stroke. So that is what is our motto, and this is some of the literature. As you can see, they are, for example, the 4, you can see 4, they have gesticulated in such a way that there no self coarticulation appears. Okay, and they, for example, this forward and backward, they designed in such a way that no self coarticulation does appear. Okay, so and another point is, basically they have limited gestures as or class that I mentioned. So that one is also another problem in the existing literatures. So they are having only 10 class or 6 class problem, and there and 4, as you can see over here, the 4 is designed in such a way that user has to remember, and 4 has to be written in that particular way, so that no self coarticulation appears into gesturing. So what we did was, basically we did the self coarticulation need to be identified, and it has to be made use as one of the information into our system design. So what we did was, we, for example, here is a 4, so we try to plot the speed versus the frame, that is this particular information, and what we observe is, for self-coarticulated stroke, the speed is basically very high as compared to the normal strokes or wanted strokes. And this is for H also, you can see, for the 2 unwanted stroke, the speed seems to be very high. So if we are able to devise some threshold, and then through this particular threshold, that is if speed is above this particular limit, then we can say it is a self coarticulation, and if it is below this particular limit, then we can say it's a normal stroke. So in that way, we try to devise some thresholding mechanism, and finally we observe that if average velocity is more, velocity of a particular frame is more than the 2.5 times of average velocity, then in that case we got an accuracy of 99.04%. So using this particular thresholding criteria, we are able to isolate the self coarticulation from the normal strokes. And After applying this criteria, for example, the age on the character age, we are able to get this particular figure. As you can see, that's it is self-coagulated removed feature. But then once self-coagulated removed trajectory, this is the actual trajectory of that character age. So we try to extract the feature out of it, and there are some of the existing feature from the literature that we have taken, and then we try to propose our own feature. And here the interesting part is basically what people used to throw away or try to avoid in some way or the other way out, that is instructing the user to gesticulate so that the self coagulation doesn't appear. So this particular thing, the self coagulation, which was one of the unwanted stuff, so we try to make use of it as one of the feature, and we define few feature out of it. And this feature, of course, I'm not going to discuss because of the time constraint. So we try to define some feature, and finally we make use of it. For example, the number of self coagulation for the 3, there is no self coagulation. 4 is having 1 self coagulation. H is having 2 self coagulation. So that is one of our feature. Then orientation of the self coagulation, so that is also one of the feature that we made use of. And then where the self coagulation position feature, where the self coagulation start, in which sector it ends, that we define. And then the O and 0 confused in most of the cases, so we try to define some of the because we have we use the 0 to 9 and we use the A to Z. So O and 0 both are appearing, so O and 0 confuses a lot of times. So we define some of the feature to remove the confusion to as far as possible. For example, the ratio of the major axis and the minor axis is one of the parameter, and in case of O, that ratio will be close to 1, but in case of 0, this ratio will be higher than 1. So that way we try to define some feature. And for example, that other features are, for example, 2 and Z, that can be differentiated. There is hardly any difference in the lower half of the trajectory points. Even in the 5 or the S, you can see there is hardly any difference in the lower in the lower half of the trajectory, but in the upper half of the trajectory there is a difference. So that distinguishing part of that particular gesture, can it be used as in a better way to distinguish between the confusing gestures? So that also we looked into. And finally, when we use the existing features, and along with only existing feature, we are getting with the neural network an accuracy, say around how much, maybe just slightly above 40%, 60%. And same with the SBM and KNN and the naive Bayes. And when we go on adding one of our proposed feature into that particular system, like position feature, the accuracy is going to improve. As you can see, we are close to 80 over here when we use one of the feature. And as we go on adding, we are moving ahead, and we are reaching towards say 90%. And finally, what we observed is basically when we use all the features, we are able to get an accuracy more than 90% in most of the cases. Even in case of especially in case of SBM and the neural network, we are able to get the accuracy more than 90%. So this is some analysis of this particular result. How much performance it was earlier. Accuracy error was 38%. How much error reduction we are able to do with the introduction of each of the feature that we studied. And we tried to capture the network structure. We did the cross validation as done in the neural network, and we buried the kernel in the SBM and tried to see which kernel performed the best. We did the cross validation, and in the KNN also we changed the value of the K and try to find out what value of K gives us the best accuracy. In case of naive Bayes, with data distribution, we try to vary and see how the performance goes. And then what we did was we fused the classifier, because what we did was we studied the confusion matrix of the different system. Now we are having one NN based system, one SBM based system, KNN based system, and the naive based system. 4 systems are there. And when we studied the confusion matrix, what we observed is the confusion is not same. In one case, the confusion between the different characters. In other case, there is a confusion between the different characters. So what we thought of, can we diffuse out the classifier and can we get a performance, enhance the performance? So we did the classifier fusion and we are able to boost the performance up to 94.58%. And what our classifier fusion gives the best accuracy, followed by SBM, ANN, KNN, and the naive Bayes. So this way we are able to boost the performance to a more than 90%, 95% near about. Okay, so we did some kind of statistical testing also, and to validate our result. So this is ANOVA testing, ANOVA and Tukey's HSD test we did to validate our result. These are on the testing that what we did on the individual numerals, only on the alphabets, only on the arithmetic operator, and you can see that in arithmetic operator only we are able to get 100% accuracy in some of the cases, and then on the total gesture set we are able to get an accuracy near about 95%. Okay, so I mean, this is what we tried to do. And then in the second case, what we did was we tried to bury the pattern. And when we buried the pattern, so what we observed is basically that, I mean, for example, the 5 allow the user to bury their gesticulate in their natural way. So the what happened? The gesture 5 is gesticulated by the 3 different user in the 3 different way. A is basically gesticulated by the 3 different user in the 3 different way. B is gesticulated by the 2 user in 2 different ways. So this is what we observe, and accordingly the number of self-coarticulation start end point of the gesture, then the number of self-coarticulation and other features that also become different. So what we tried to do was, okay, we have the existing feature and we try to propose some of the feature that is invariant to the pattern, that is pattern invariant feature that we try to derive. And for example, if you see this 5 only, then we divide the 5 into 2 halves, and in the first half we find out the start point and the end point, and in the second part, right part, we also try to find out the start point and the end point. And what we observed is basically in the 3 different cases, even the start and the end point is different, but the orientation parameter, that is orientation feature that we used to derive, that is for, this is for the start point, for figure E is for the start point. So this is almost same, and this is for the end point, and this is for left half start and the end point orientation. This is for the right half and start and the end point, and they are coming out to be almost similar. So what we are able to do is we are able to derive some pattern independent feature that can help us, even the pattern variation is there, but the feature will be, I mean, independent of this particular variation. So in that way, we design some parameters and we try to plug in that particular parameter into the system. And what we observed is, as we go on adding the parameters into the features, so features we are able to get an accuracy with the neural network as 88.96%, which of course degraded as compared to the previous system, which was giving more than 90% accuracy. So I mean, it got degraded. And one of the interesting point is basically the SBM, which was going to outperform the ANN, is now the ANN is showing better performance. This may be the variability introduced into the data and type of the feature that we made use of to capture the information. So we did the similar way, the cross validation, I mean, selecting the type of the kernel, I mean, what is called, that is capturing the network structure, and bearing the k-values and the distribution, and we try to do the cross validation, and we observe that in this case, that is the neural network outperform the individual classifier. But when we combined all the classifiers, we are able to get an accuracy of 90.42%. So with the pattern variation being allowed to the user, so the system performance degraded roughly by 5%, 4-5%. So, and in the third case, what we did was basically pattern we freezed out, that is pattern is fixed, and we allowed the user to vary their speed, that is the way they used to write. And what we observed is basically, I mean, when we allow the user to write in their natural way, then the speed varies drastically. And one of the observation is basically that as the user used to write in a very high speed, so the number of I mean trajectory points are very small. And as the user write in a very slow manner, then the number of trajectory points are getting more. So once this is being smoothened out with the Douglas-Pecker algorithm, the number of points that becomes very less when the user write in a very fast manner. So it becomes really a problem to identify the features and all, and it leads to a kind of chaotic situation. So what we did was we tried to have some reference pattern, and once the incoming pattern is there, I mean, say for example, we have the 40 gesture pattern for corresponding to 0, we have a reference pattern. Corresponding to 1, we have a reference pattern. And what we did was when an input gesture is coming, we picked up one of the pattern based on the DTW and Euclidean distance measure, and we picked up that particular pattern and try to extract this one. For example, this is one of the case where the users are writing the 2 at 3 users are writing the 2 in a different speed. So in one case you can see number of pattern is very good, number of trajectory points are very good, and in the other cases you can see there are very less number of trajectory points. So these are some of the problems that we face. So what we did was basically we tried to make use of the dynamic time warping technique, which is very popular in the speech processing areas for time registration of or time alignment of the 2 speech signals spoken at the different time instant. So that particular algorithm we try to port it over here and try to make use of it for the template alignment in our case, template trajectory alignment in our case. And in the first level, we try to make use of the DTW, and the second case we made use of the Euclidean distance measure. Okay, so this is how the things goes. We have the reference template. We make use of the DTW to find out the 10 best matches out of the references, and finally we made use of another feature, that is the feature F2, F3, 2 features, and out of the 10 we try to best select the based on the Euclidean distance measure, we try to find out the best reference template. So once we got the reference template, so that particular reference template is made use of for designing our system. So when we tried with the 2-level alignment, the 2-level alignment speed alignment technique, that gives us an accuracy of 99.25% accuracy. So this is what, that is the feature 1 is used that for DTW alignment, and feature 2 and 3 we made use for that one, that is the picking out the 1 out of the 10 best. In the first case, feature 1 is basically used to select 10 out of the 40, and in the second case we try to select 1 out of the 10 using the feature 2 and the feature 3. So this is what we did, and we used the existing feature and our proposed feature, and what we did was we did some kind of feature selection technique on the top of this one using the ANOVA plus IFS and various other statistical methods. We try to make use of for feature selection, and finally what we did was we observed that the ANOVA plus IFS, that is incremental feature selection. ANOVA means analysis of variance, plus the incremental feature selection technique provides us a good accuracy with the ANN architecture and with 23-dimensional input feature. And as the number of feature is basically increased, the performance degrades. So with this with this particular input features, when we design the system with the respective input feature, we design the system and tested it out, we are able to get an accuracy of 93% with the ANN classifier, and with the fusion of the classifier we are able to get around 95%. This is a good accuracy for the speed variation, and we are able to get a close performance with respect to the first experiment, that is reference template and the reference speed. We are able to get this accuracy with the speed alignment method. So we did some kind of analysis with the existing model and our proposed model on the different data set. For example, numeral, alphabet, arithmetic operator, and self-coagulated gesture. And what we observed is that our proposed system beats the existing system as well. So then what we did was we have some system at least ready for, I mean, the color marker. So we moved to the bare hand, and the first problem with the bare hand is basically the hand detection. So we tried to do the hand detection. We modified the existing hand detection technique. We tried to port out a concept known as the three-frame differencing technique, and we try to make use of it using some binarization and morphological operation. We try to integrate along with the skin filtering technique. And what we observed is, for tracking also, we modified the KLT tracker, because the problem with the existing KLT tracker is that once it goes on tracking, the number of points, feature point reduces, and then there is occlusion, then I mean the tracker fails in some of the cases. So what we did was we tried to make use of the compact criteria and the velocity based feature selection and camshaft algorithm to refine the region of interest, and we tried to feed it to the KLT tracker, and we observed that under this particular scenario the KLT tracker perform better than either single KLT tracker or the camshaft algorithm working alone. So what we observe is that our system proposed modification on the hand tracker that perform well as compared to the camshaft, KLT, or particle filter, and we are able to get the accuracies as close as to 100% under different conditions. So with this, we try to design our bare hand gesture recognition system, and what we observed is that we are able to get an accuracy of close to 90%, and with the fusion of the classifier, we are able to get an accuracy of slightly more than 90%. So then what we try to do is that whatever experiment we did earlier, that were basically on discrete gestures. So what we did was we tried to make use of this discrete gesture recognition system for continuous hand gesture recognition system, and try to see what is the problem. So the problem is basically when we go ahead with the continuous gesture recognition, the problem is basically that you have to separate the movement hypothesis and the self-articulation. So here is an example of say in that particular case, the ABC is basically a sequence that is written in a continuous manner. So here there is self-articulation as well as there is movement hypothesis. So which one is self-articulation and which one is movement hypothesis? So that need to be identified, and accordingly the gesture A need to be separated out of gesture B and gesture C, and that can be fed into the dynamic gesture recognition, discrete gesture recognition module to identify that yes, it is A being gestured, B and C, these are gestured in a given sequence. So that way we try to design some technique based on the pose information, because the two criteria that we made use of is basically that pose, because if there's a movement hypothesis, the pose will be more before and after the that particular movement hypothesis or the unwanted stroke. So this piece of information, along with the other information that in case of self-articulation, the original gesture stroke starts immediately. So that is another piece of information that we try to make use of, and we try to design a particular technique to identify the self-articulation and the movement hypothesis, and that with this we are able to separate out the movement hypothesis. This is an example. What it shows is if we gesture the ABC, and each segment, what is the each segment represent, for example, from head to hair, and so on. And then if we apply our criteria, that is, and this is the how we are able to get the A, B, and C after applying the which one is self-articulation and which one is basically movement epenthesis. So if we are able to find the movement epenthesis, then we are able to identify this is the end of one gesture and beginning of another gesture. So in that way, we are able to identify that where the A start, where A ends, where B start, where B ends, and so on and so forth. And we can identify the individual gestures, and we can feed it to the classifier that we have already designed, that and we can make out a meaningful information out of it. So that way we tried it, and we are able to so these are we tested with the ANN, and we are able to get an accuracy of 89.81%, and with the SBM 88.69, and it was shown that the ANN outperforms the other classifiers in our case. So classifier fusion boost up the performance a little bit, but to 92.7%. So then we move to 58 gesture recognition system. That is, we tried to, along with the 40 gesture, we try to put the other gesture, that is some special character, into our system. And so once we put the special character of the characters into our system, the system performance degrade. So we define some kind of new features, and we try to make use of the existing architectures, and we observe that the NN with the IFS, ANOVA with IFS with SBM machine, that provides us the best performance. This experiment we did, the 58 character that we did with the reference pattern and the reference speed. So we extended the database one, as I have mentioned over here, we extended the database one, and we did the experiment with the special characters. And we observed that in that case, so at least with the initially the performance was degrading like anything, it was coming around 70%, but with the introduction of the 3 new features into that particular model, we are able to get an accuracy of around 96% with 58 gestures. So we are able to get a significant improved performance. This is where the confusion arises, and all, for example, gesture O confused with sometimes with gesture R, and with 0 confused with O, R sometimes confused with O, and so on. So I mean, this way we defined some of the new features and tried to take care of the increased vocabulary into and its effect into the design of a dynamic hand gesture recognition system. So here is an example of the hexadecimal keyboard that we tried to design, and that you can just check it out. So she's gesturing. So as you can see, so A1 plus 2B, as she has written, gestured out, and the result is CC. This is basically an hexadecimal output of a hexadecimal keyboard, and this is a hexadecimal keyboard where the text character are being entered, and she is gesturing out the NITS, and the screen output will be displayed as NITS. So as you can see, as you can see in the command, NITS is being displayed on the screen, showing that she gestured out the NITS, and you can see that NITS is basically the output of this particular system. Okay, so that way we try to design hexadecimal keyboard and our numeric calculator and hexadecimal calculator also. So anyway, so what we tried to do was we did some kind of feature engineering. We did some kind of pre-processing technique like 2-level speed normalization. We try to discover some kind of new feature, what basically is known as the feature engineering into just machine learning or artificial intelligence literature. So with this, we are able to design some kind of system that provides us an accuracy to a reasonable level. So as a future scope of work, we have a lot of characters. For example, the lowercase need to be incorporated into the system. There are other printable characters in the ASCII keyboard that need to be plugged in into the system. And then there are a lot of other challenges like pattern, speed variation, then background variation, illumination variation, and all other challenges that need to be fixed out to have a system that can be a really useful one, and that can be made use of for a practical application. Other than this, the recent trend is basically the deep learning models. Here, as I mentioned already, we have been using the shallow architectures, and we have been doing the feature engineering and pre-processing and the post-processing to certain extent to, to enhance, boost the performance of the system. So deep learning model can be explored to boost the performance of the system. So these are some of the references that I made use of. And here is some of the stuff that I would like to show you. For example, this is a particular system, and you can see that here the two hands are basically you made use for the gesturing. In our case, we use the single hand for gesturing. There are sign language, for example, in the sign language, the two hands are basically made use of for gesturing. And here you can see in this particular example, this is where two hands are basically made use of, and there are complexities in this kind of system also, because sometimes when two hands are moving, one get overlap with the other, and your TLT tracker on the other tracker fails, and then you need to have some kind of solution to address this particular problem. Here you can see, as I told you, that it's a robot being gestured out. Of course, it is a data globe kind of system that is contact based, but vision based system can also be made use of for the robot to pick up something, or drop something, or it can be a crab nurse is there and that crab nurse is basically based on the command of the nurse, it will bring the surgery tools to the nurse. So that kind of system is basically there in practical field. So this is one of the application for Angry Bird, where the TV application is basically controlled with the gesture. Here is a virtual gaming application where the car is being controlled, or other devices are being game is being controlled through gesture. And as you can see, here is a Sunnybrook Hospital that utilizes the cameras to control MRI, CAT, and CT scan imagery during surgery. So this is in use in Sunnybrook Hospital. Then gesture recognition system for medical application, as you can see, for controlling the MRI, CAT, and CT scan imagery. And then you can see here is the gesture-based system, where gesturing is used to control the appliances in the handheld devices. Here in the commercial application, the lady is selecting, choosing the garment with the gesture-based kind of application. So, and here is a gesture-based kind of application for in-car applications or in-car control applications. So there are a lot of other applications that are basically made use of, and even you can have that is the for movie lovers in some university in Israel. They are using some hand gesture to control the select the movie for out of a large gallery of movies. And you can see that in the Purdue University, for example, they are doing research on the medical application of the gesture. For example, I mentioned that I showed you that particular application where the gesture can be used to bring, or robot can be given the command using the gesture to bring some surgical tools to the doctor and all. So this kind of application are there. People are trying out, and I believe you can see more and explore further. So thank you all. Thank you.
Okay, well, sir, thank you for your nice presentation, sir. So few questions are there. So right now you want to answer, sir, or should we mail you to Institute ID? Okay.
Yeah, whatever you like.
Yeah, yeah. It
Yes.
depends on you. If you only three questions are there, sir. If you want to answer, you can answer, sir.
Yeah.
So
Mm. Yeah.
those
What are the questions? I mean,
uh, those are in the chat section, sir. Chat of the Google Meet. So that has been written, sir. You can read from there.
tell about.
In Google Meet, in chat section, you can see, sir. First question is that as compared to keyboard or mouse, how fast DHDR works? How much latency is there?
Dynamic, yeah, yeah, that one. I mean, our implementation is still in the MATLAB platform, so we are not able to gauge out or find out what is the, I mean, the latency of the system. Once we will be really implementing it on a better platform like Python or OpenCV and all, then we will be able to see, I mean, what is the performance of this particular system. Huh? So, I mean, we are half the way basically for implementing the system. Yeah.
So second question is usage of deep learning in dynamic hard gesture recognition. Usage
Yeah,
of
we can make use of the, I mean, as I mentioned in my last slide, we can make use of the, I mean, deep learning architecture. But in this case, what we need to do is basically we have to give a 2D representation of the 3D video, 3D video. So that 2D representation, 1 degree of information we may have to lose out, and accordingly we can design a 2D, because ultimately at the end of the day, the gesture we got converted into 2D image, and 2D image processing we can make use of. Other than this, what we can do is some temporal information is there, and the spatial temporal kind of, I mean, architecture we can make use of for, I mean, the for the system. Yeah.
So last question is that sir tell about CFT features
I'm
and
not
what
getting. In
uh,
fact, what about the CFT feature? I believe I am not mentioned about the CFT somewhere. I'm not
uh,
getting about the exactly what CFT feature he wanted to mean. So I mean, we try to derive our own set of feature along with the existing feature, and some of the features are novel in our case, and they have been, as you know, the feature engineering basically done on the it's a handcrafting basically, and you have to look, observe, and according to your application, you have to design your feature. For example, to the O and 0, so that can be distinguished based on, I mean, the, I mean, major axis to minor axis ratio. So that's what we try to did. We did some kind of feature engineering, looking into the, I mean, features and trying to see, I mean, how this feature will be going to help us out in our application. So that's the way we did. Anyway,
okay, sir. So now we are going to conclude our session, sir.
yeah, yeah, sure, sure. Thank you.
So we the participants especially. So our highest gratitude to you, sir, for being with us and sharing your valuable knowledge and experience with us. We would like to thank Dr. Rabul Hussain Laskar for taking out time from his busy schedule and providing us with an opportunity to learn from his wide range of research experience and knowledge. We assure it has been a big learning experience for all of us, and all the participants must have benefited and noted down ideas from their future research work. Sir, we hope to get such opportunities in your future also. Thank you, sir.
Thank you very
Thank
much.
you all for attending today's sessions. The next session will be resumed tomorrow at the tentative schedule. Thank you.
Thank you.